All right, well, welcome to the HoloViz tutorial. This is, HoloViz is an open source project. You'll see lots of examples of it. The main ones we'll focus on are hvPlot and panel, so if that's what you're here for, you're in the right place. Just as background for me, how many people are from a geospatial background? Okay, so not quite half, okay. That means I have to say everything. I can't ignore either side. So I'm not from a geospatial background, but the examples are geospatial because it's readily understandable by everyone. So the people who are not from a geospatial background, please realize these are fully general purpose tools you'll see. Even though the examples have maps on them, just take the map off. There's nothing special about it being about maps. But everyone can look at a map and know what the axes are. So it's helpful for this type of tutorial. But also, there is some special support for geospatial work. So I'll try to highlight that when we encounter it, since we do have a third of you or whatever who are geospatial. Okay, and then quick show of hands, how many people have been using Python for less than 5 years? Okay, how many have been using 5 to 10? More than 10. Okay, I got to cover all the bases there too, perfect. You'll keep me on my toes. All right, so if anyone is having trouble with the environment, please make sure you put the red Post-it. Ian will come help you out. Meanwhile, I'll move forward. I won't immediately be using the environment, so if you're not quite there yet, don't worry about it. If it's still installing, you'll be fine. Be 5 minutes at least. All right. I'll briefly touch on some news here. Just so you know, HoloViz is now a fiscally sponsored project with non-focus. That means it's got a board of governance, a committee that runs it. It's all legit. But we'll come back to the news and really talk about what it is first. Let's see. All right, so the starting point, of course, would be holoviz.org. And HoloViz consists of a set of libraries that are each individually usable. You can download one and never hear of the others and don't care about the others. We're going to focus on these first two here, which we think are the best entry points. And we'll dive into that. Before we do, I just want to give you just a simple example showing what sort of thing you're leading up to if you take this tutorial. And all the examples are at examples.holoviz.org, or they're linked on the individual websites, like the panel website or the hvPlot website. And so just wanted to show one example application that is built using these tools. So actually, let me zoom out. This is a HoloViz app that uses most of the tools in HoloViz. And so it is both a way to explore data, but also a way to share data. And you can do either one with these tools all the time. This particular one, the overall, just to sort of break it down so you can understand the packages, the overall page is a panel app being served as a web server. So you can see if you look very closely, it's on a port on my local machine, and this web page is just visiting that port. So it's a web server that answers to that address. And sitting there is a web server. It has an associated Python process. When I do certain things on the map, it'll call Python code. And so, so it's a web page, but if you drag things on the map, on the web page, when I do this, it invokes Python code and then the page just gets updated. So that's the basic idea here. It looks like a web page. It is a web page, but behind it there's a Python server. The Python server is doing computation in response to your actions. And so one action you could, so this particular one happens to be showing the locations of 200 million pings of GPS coordinates from ships. So the ships have a little GPS coordinate on them. They announce to everyone in the vicinity where they are and what their identification is. And then all along the coast of the US, there are recording stations that'll collect those, and then those are all pooled. 200 million of them are shown here, and they're categorized by the type of vessel it is. And so if you look, if you zoom into this, so you'll see that it's briefly blocky and then it gets redrawn. That's Python. So as I zoom in, it's asking the Python server, hey, I need to show a certain level of resolution, and it's delivering that. And if you zoom in a lot, it'll redraw it. And so now you can kind of see by color, these are fishing vessels. You can see that fishing vessels do a certain pattern of movement. They tend to fish, whereas cargo vessels tend to go in a straight line somewhere very far away. So you can see that there's a very clear relationship between category and kind of behavior in this map. And this is not they actually do go straight and then straight over. It's not just connecting dots. And if you zoom in enough, you can see all of the underlying data points involved here. So each one of these is a ping from a moving vessel. So the vessel is moving along this and pings. And so it all ends up in a big Pandas data frame. The Pandas data frame is sitting there in Python memory. This web page is showing you a way to look at it as a human being, a way to interact with the data. You can explore it, see what, like this particular one happens to be a cargo ship named the C-SPAN Hudson. Don't know anything about that. If you click on a particular area and scroll the page down, it's hard to get to the page. Okay, so here I clicked on a particular area. It looked up that particular ship. That particular ship was called Snowy, has this ID, it's a cargo ship, and here's a picture of it. So this is the type of thing that I would like you to be able to have the ability to do, is to take a data set, turn it into something where there are controls, there's visualization, and it speaks to you as a human, and you can share it with other humans. That's what this tutorial is about. If you don't want to do any of those things, you shouldn't be in this room. Assuming you do, we're going to sort of unpack this and show how to do this type of thing. And here it's shown for points. These tools are meant to be fully domain general. They can show points, lines, but also images like satellite images. They can show microscope images, multidimensional stacks of data, movies, meshes, for people who know what a mesh is, networks, pretty much anything you might want to do. So these are not tools that are tied to a particular domain or particular field. So that's basically where we're headed. And now we'll get started unless there are questions or someone immediately having trouble that's not being addressed. I see everybody's, I don't see any red on laptops. So we'll get started. Okay, so first off, yeah, are there any questions or issues? Okay, let's go then. So if you follow the setup instructions at holoviz.org tutorial, you can do this at any time. This is a permanent website. We update it, and we are expecting to update it in the next few weeks, so it'll have different content, but there should always be a tutorial there. Once you follow the tutorial setup instructions, then you'll end up it should actually look like this when it launches. It should give you a Jupyter server. Jupyter is doing exactly what I just said that other app was doing. It started a web server. It's at a local port. It's got a Python process sitting there, and it's displaying in a web browser. So Jupyter is one type of app, that a very specific type of app that's used for development, but it's the same process as any other app you might build with these tools. So now that you've launched Jupyter, you go into the tutorial and accidentally start some other thing. So launch the setup, and part of the setup instruction is just to run this whole page. I always do restart and run all, because I don't trust myself 5 minutes ago. I don't trust whatever's there. Oh, there was one question. I just saw some of the audience that reminded me. How many people have previously been to a tutorial like this one? Like the actual HoloViz tutorial? You never had, Scott? I think so. All right, well, welcome. So if you need help, Scott can probably help you. He's an honorary member of this tutorial staff today. All right, so here I don't need any help. Look, I just ran the notebook. It completed with no errors. It showed me these little logos. That means HoloViz is running. It's got bokeh available and matplotlib. You probably can't see the matplotlib logo. And it's checked that the data is there. If it fails at this stage, you had some problem downloading your data. Okay, and then that's all you need this notebook for, is the basic testing. And then move on to this notebook. This one's actually just a set of slides. So I'll quickly go through these. Again, if you don't have it quite ready, this is your chance to catch up. Okay, just start from the barest principle. Why the heck is it called HoloViz? Holo is a Greek root that means whole, entire, complete. And these tools are meant to sit on top of other visualization tools and solve all the problems that sort of fall in the gaps between your visualization tool and your data API, for instance. Like if you're computing a histogram, is that a plotting thing or is that a statistical operation? If you are using a plotting library that doesn't have it in it, then it's solved here. So basically kind of it's trying to address some of the problems that are left unsolved by a standard visualization tool and that require a lot of work by users individually. And kind of the more important meaning to having it be hollow is that we strongly believe that you need to make it easy to visualize things at every single step so that you are understanding every single step. I'm pretty sure I didn't come up with this, but I have a saying that if you have a black box somewhere in your system, that's where all the bugs will go to hide, because they don't like the light. Once you shine light on them, you see them and you get rid of them. And so you get rid of them here, 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 and then this black box. There shouldn't be a black box. There should only be clear boxes, only open boxes. Visualize that, visualize everything. The whole system, all over the place, all the time. Because you're a human being and you work with eyes. Well, if you wanted to do the same thing with your auditory system, go for it. Use one of your sensory systems, though. Don't leave it in computer form. Put it in a form that you as a human being can interact with directly. So we really strongly believe that that is the way that you will achieve correct results, insight, understand opportunities, and more often kind of boringly find problems all the time, every day. And as an example, I run the consulting division at my company, and I can't tell you how many times we've set up a machine learning project. Step one, we're gonna go get some data, and then we're gonna look at it, and then we're gonna do this fancy machine learning algorithm. I can't tell you how many times we never got to the machine learning algorithm because as soon as we saw the data, we knew what to do. Oh, it's easy. Oh, you can see that's in 2 categories. Put a little divided line. Done. That's it. Or your data is complete nonsense. Why feed it to something? None of this is any good. Start over. And this has happened over and over. So you're talking to a visualization zealot. So that's what you're in for. But I strongly believe that. So anyway, Python has tons of tools. This is an old slide. Many of these libraries are gone now. But it gives you an idea that like if you're in R, you use ggplot. Of course you do. If you're in Python, you use, okay, matplotlib. But for everything, which covers lots of things. But everything else has been created because matplotlib doesn't do everything, doesn't do it the same way that you might want to do it. It hasn't historically been optimized for a web browser. It does work. It can be interactive in a web browser. We'll show you examples of that. But other people have said have really tried to focus on the web as a real target. And then other people have focused on three-dimensional visualization. Matplotlib has 3D plots, sort of, a little bit. It's not its strength, so there are a lot of other tools around it. And then there are others that try to build on plotting solutions from other languages. It's kind of a mess for users, and what we've tried to do is is identify a subset of the tools and say, hey, we're going to make it super easy and super powerful to use this subset, and use other tools if you want. So we have chosen to build primarily on Bokeh and Matplotlib, also a little bit of Plotly. And then we have a certain set of principles, and then hopefully you'll agree with those. If not, at least you'll find them useful. So number one, all tools support web browsers, and that's because we move casually between local compute and cloud compute. Local stuff, some server. If you're tied to your desktop operating system, that is a mess, because now you're copying data around all the time. You're having to go visit the lab when you want to stay home in your jammies. No, everything supports a web browser. That's all you do. But our audience is not people who are web front-end engineers. We don't assume you know JavaScript. We don't assume you know HTML and CSS, how to tweak that. That should not be your job. Your job, if you're coming to SciPy, your job is usually you're a scientist or a researcher or an analyst, and you're trying to get something done, which is not about making a pretty website. So we're trying to let you stay where you are using Python the way you're comfortable with, but then reach people using the web browser. And maybe someday, eventually, with PyScript and Pyodide and WASM, we'll get rid of all non-Python things in the world entirely. But for the moment, these are ways that let you write Python and share it on the web. And importantly, they will work with literally any size of data. I mean, petabytes. So if you have access to a large enough cluster on the web and somewhere in the cloud or at a supercomputing center, HPC system, these will work. And why will they work? Is just imagine there's 1,000 processors. Let's say each one of them might own this little chunk, one might own this little chunk, this little chunk. They can each render it individually using the data that they have locally, and then those renderings are assembled, and that's what you actually see. So you can handle petabytes as long as you have enough computing power to work with petabytes. It's all done, everything respects this being a distributed set of data. So maybe you don't care about that, but if you choose these tools, it means that you're scalable. It means today you use them, tomorrow you have a big problem, you have a collaborator who's suddenly got 100 times more data, no problem. So that's another principle here, that it's scalable. Another is that we love Jupyter, but we're not always in Jupyter, because sometimes we're sharing our public-facing web server. Jupyter is a fairly expensive way to do that. You can do it. You can use technologies like Voila that allow you to share your Jupyter session in a read-only way that looks pretty. But each one of those is a full Python kernel, Python process. That's expensive if you have a lot of users. So our tools support Jupyter or standalone web servers that can be as efficient as you want, get rid of shared state that really can serve lots of users at the same time. So if you want that, that's available. And the other principle is that all these tools are meant to be really quick to get your job done when you don't care a lot, and then to have a gradual decay into amount of code. So if you're not opinionated, your code will be very, very short. The more opinions you have, or you don't like that, oh, fine, you change that. You change this, you add custom behavior, custom whatever. Then your code gets longer and longer. But our principle is that by default, when you're just going about your day, doing your research, if you just want to see your data, you should be able to just see your data, and it should be a tiny number of lines of code. And there should be simple, direct code. And finally, we believe that we should be respecting any API that is in common use that is sufficient. It may not be the perfect API, the best way to specify plotting, but if you already know it, then it's way better than learning some new elegant one. So for instance, I'll show you how to use the standard Pandas plot API to get lots more done than would normally be possible with that API. Okay, and like I said, these are HoloViz libraries. These were all developed individually before there was such a thing as HoloViz, but all the people involved have been collaborating. The main core of this group has been collaborating for 10 years now, some of us for 15 years. And so we kind of made everything work together, and in the end we realized we need a name for that thing. What are we doing here? So this thing we decided to call HoloViz. HoloViz is a NumFocus sponsored project. It's an independent entity, not tied to my employer. The tools actually started when I was a professor in academia, so they're independent of any company's control. We have Scott is on our steering committee. I think Sophia, co-chair, but she's running. Oh, Sophia is also on our steering committee. Hello. So we have a formal governance process. It is not controlled or owned by any one of us. And very briefly, since I will only cover some of the libraries in the tutorial, Panel is what lets you set up web pages like this, or put little interactivity bits inside your Jupyter notebook. So we don't have any opinion about whether you're making a tiny little thing with one slider, 0 sliders, an enormous app, a multi-page app that's re-implementing Excel. Do whatever you want. Maybe don't do that. So Panel is our kind of app and interactivity entry point, and then hvPlot is our data-centric entry point. You start out with a data set, and then you want to do everything with it. Then pick up hvPlot. If you think, I'm going to make an amazing app, pick up Panel. So those are your two basic things. What are you doing on a given day? And if you really care about the app, start with Panel, and maybe you can stick these other things into it. And if not, if you really want to think, I've got a data set and I want to do this, or a data set and do this, that's hvPlot. hvPlot builds on libraries you don't have to worry about today. HoloViews, GeoViews, which is the same as HoloViews, but adds projection capabilities using a legacy geoscience stack that you do not want to have to install, which Michael Sarahan there did a lot of work to get that to install, but it's still brittle. So you want to avoid GeoViews unless you need that. If you need it, it's great. And you probably have those installed anyway if you're that sort of researcher. Data Shader is what we have that does the server-side rendering. So you had 1,000 different CPUs working, each processing a little bit of the data, and then collecting all of that and displaying that. Here, this app is actually running entirely on my laptop. So there's not a whole lot for that to do, but it could be, and this is 200 million points on the laptop. This could be petabytes of data across many machines. It would look the same and work the same. And then Lumen is actually Panel in YAML. So if you don't want to write Python, you can actually specify entire pipelines that lead to apps as a declarative text format. And the great thing about that is that anything that's in Panel can show up in Lumen, so including anything custom that you add to it. So imagine it's like a BI tool, but it's one that can easily harness the power of Python. We will not get into that today. It's still pretty new and not very well documented. And everything's built on param. You'll hear a little bit of that, and I'll get to that. And then color set is just a collection of color maps that make everything come out clearly. So, and then in this particular app, we'll be building up to, in this particular tutorial, we're focusing on building up to this, an app like this, which has a web page, gives you a couple of sliders, allows you to select some range of data to display. Once you select the data to display, then you can select the data on the display and see how it all relates to each other. Like select a range of the table and see which data points those are. Select a range of, in this case, this is earthquakes by magnitude and depth, depth from the surface. So you could select, give me only the very deep and high magnitude events, and it'll show you where those are. And you say, oh, okay, well, yeah, but I meant only the ones in South America. And you select that. Okay, so that's what we're headed towards. just being able to decide what to display it, and then interact with it. So I'll take a breath there and see if there's any confusion or questions before we dive in and start to do it. Okay, well, let's run the thing then. So start on O2 plotting. I'm going to go ahead and restart and run all, but you should probably just do it one by one. I'm just going to show you what we're heading towards. And this one, I turned off some Python warnings. There's some things in the environment that are not exactly in sync with other things, so they're complaining about deprecation warnings. So I turned that off. So you'll see some warnings probably in your version. We are in the midst of updating all of these libraries and this tutorial, but there's a big chunk of work that's not yet appeared. So it's not, we don't have the latest versions of everything yet. Okay, so this tutorial is going to start with Pandas. How many people have not used Pandas? Peer pressure, come on. Okay. Okay, so you'll see Pandas now, but so you import Pandas, and then here's where we're headed. We're in this notebook. We're going to go from start to being able to have something. So we import Pandas. We'll read some data. We'll look at the data. Then we're going to do a quick plot of it, and then we'll plot it using a different tool. And then we will see how to get help with that. Then we're going to plot it at thousands times higher resolution. Then we're going to plot all the data. And then show a few different kinds of plotting options. So that's where we're headed to in this one. I'll go ahead and clear the output just so you can follow along. Okay. So we're importing Pandas. Pandas is a library for columnar data. So a lot of people use Pandas without thinking deeply about it. Pandas is great when you have a table with columns. They might be different types, and then an arbitrary number of rows. Not all data is like that. The other main category is in-dimensional data, where it has rows, columns, time, density, wavelength, like arbitrary possible many different dimensions. Just imagine scanning a sample and you measure certain physical properties of it. At every spatial location, there'll be measurements of it, and you could have any number of dimensions. Pandas is not good for that. So we're focusing on that. These tools equally support multidimensional and columnar. So we'll start out with columnar. That's what most people, that's their entry point. So here we're reading a Parquet file. That's important because this is a fairly big chunk of data. Parquet is a very efficient format. If you haven't heard of it, just imagine it's a CSV, but converted into binary form with little chunks that are easy to access. And so if you don't need a column, you don't even read it in. If you don't need a range of rows, you don't read that in either. So you read in a chunk of a row here and a chunk of a row here and get your work done and ignore everything else. So it makes it vastly more efficient than having a CSV file they read and parse the whole thing. So, but if you know CSV, it's just the same, but slower. I mean, Parquet is faster. So if we do that, it took us a couple seconds to read it in. Let's look at this data. It says I'm going to count here, it looks like it's 2 million rows and 25 columns. So here, this is the result of df.shape. So this is a columnar array with 25 columns, 2 million rows. And so if we look at the first 5 rows, and we get all of the columns. So what is this stuff? This is a data set from the US Geological Survey. And it has index of time. Here we actually set this. We set that the time column should be the index of this data frame. It just makes it pretty obvious what to plot if you declare the index. It's kind of a detail. But you say, this is the one column that everything else is organized by. So you can see it's organized by time here. And previously, there would have just been a number for the index. And then for each row, each of these is an observation. So I believe this is a tidy data set. It looks like it is. So a tidy data set is one where you have an observation and then a bunch of different measurements. So you measured some particular event. In this case, it's an earthquake. The earthquake happened at a depth of 7.8 in some units. I'm not an earthquake scientist. It has some uncertainty associated with it. Some other fields I don't know anything about. This is probably about how spatially localized it is. It's got a location, and latitude and longitude. It's got a unique identifier of some sort. There must be some entities that assign names, identifiers to them. We've got some skipped fields. We'd actually have to look to see what's there. And obviously a lot of curation. That's good to see. Time of the event. And then easting and northing. If you're not familiar with that, it's just starting at Greenwich, how far, how many meters you are west of Greenwich and how many meters you are north of Greenwich. So how much, east, it's easting. So it's a negative number if you are here in Austin, Texas. So start at Greenwich, the easting increases until you get here. It's basically longitude reformulated in terms of meters. The reason for having that is that's what web-based mapping services like Google Maps, they're all based in this coordinate system. So if you're not a geospatial guy, then just accept that that's how these maps work. If you are, then you're going to complain about it and say it's a horrible projection and we'll have to fight later, okay? Okay. All right, so this is your data. And if you look at it, can you see what, you can see lots of data and you could just page through all of it. But it'd be very hard to appreciate anything about it. You can see it's got some names, some ranges. You might think, maybe I could plot a histogram of the depth. I mean, you can just think of what you might do with this data. How do you understand it? How do you make any sense of it? Imagine you're a new student in the lab and you were just given this data set and they say, go write a nature paper. How do I write a nature paper on this? So you probably come in with no hypotheses and your first job is to explore. So that's what we're going to focus on, making it easy to explore and come up with hypotheses, notice things, weird things, what's interesting things, whatever it is. So first, we'll make our job easy by taking a tiny little subset. HoloViz tools don't need a tiny subset, but traditional tools do. So we'll first do it the traditional way to show you the difference. So now we're working with 21,000 data points. That's a tiny, tiny data set by these standards of these tools. Same 25 columns. Here notice that it says 5 rows. That's just because I took the head of it. That's why I also printed the shape so you can see it's 21,000 rows. Okay, so you've got this. Pandas is designed to support easy exploration. That's what it was. It was developed in that context. So if you use, Pandas has built-in support for matplotlib. The totally standard typical thing to do is to do a matplotlib plot of something. Here, let's use latitude and longitude. These are clearly things that humans understand, the longitude axis and latitude axis. And I don't know if you can see patterns in there. Can anybody see shapes that are meaningful to you? Like maybe this one? Does that remind you of anything? Maybe this one, if you're Pacific oriented. Maybe this one, if you've been to Alaska, the Pacific Northwest. I mean, you can sort of see some stuff in here if you're on the right drugs and you're really imaginative, and you can sort of see stuff, particularly if you know what this is. This is the Earth, right? Where do earthquakes happen? Well, they happen where stuff is going on the Earth, and where stuff is going on actually turns out to be continent borders and some other stuff. So the edge, like California, you've heard they've had earthquakes there. There's a lot of earthquakes there. Alaska, the Pacific edge of South America, the westerly edge of Africa. Okay, so you can sort of see stuff. This is a scatter plot of 21,000 points. And do you see 21,000 points? Like if you were to count these, would you think you would reach 21,000? Okay, well that's because a lot of earthquakes happen in the same place, so I suggest you move if you're in that place. But you can't tell that from this plot. You just happen to know, because I told you, focus on how many data points you had. So you knew there were 21,000, but you look at this, you might be forgiven for thinking there's 300. Okay, so here we're using Matplotlib's inline plotting support. That gives you a little image. So I can drag it around and open it in a web. Here, this is just an image. It's a PNG, I believe. It's totally static. But we can change that. I actually haven't tested this in a while. So let's see if it works. Sometimes you have to reload everything. Okay, look, we got interactive controls. So now we can zoom in. There's supposed to be little, Matplotlib has icons. One of those is zoom. I'm going to assume it's that one. Nope, that's pan. I assume it's this one. Yes. Okay, so we can zoom in and see that there are actually, see how many data points there are in any particular location. And then there must be, yeah, the home resets that. So you can, if you find something that's really got a lot going on, California has a lot. Okay, so you can see that you can use, the interactivity is super important here, because without it, you really don't have any idea between 100,000 things overlaid and 2 things overlaid. They look the same. That's a problem called overplotting. We'll get to that. All right, and so that's the default. You will always have that available if you've done a normal Pandas install. You'll always have this bare level of plotting. You do have to install IPyMPL separately. I don't remember the command for that. It might be called like conda installed IPyMPL, but I think it might have another name. Anyway, so that's optional support. But we're going to focus on hvPlot, which allows you to use the same API. So we don't want you to have to learn anything new, but then you get a whole lot more. The first thing you get more is interactivity out of the box and things like hover, so that if here I've gotten rid of, it's only got latitude and longitude, but if you left other columns in, it would show you something useful about it, like the name or the event or the time. So here the hover is not that useful, but you can decide what goes there. It's an option called hover calls, hover columns, and then specify that you want to see the name or the date. And then you can learn a lot about it. For instance, if you hover over this point, you see there's one thing there. Hover over here, you see there's 5 or 6. And you hover over here, you see there's more than fits on the page. So that's at least a clue. Maybe you ought to zoom in there. So that's helpful. And this is the support here. This is native bokeh. This is a bokeh plot. That's what this little symbol means. Bokeh is built around really solid JavaScript support for plotting. And bokeh was designed for Python to use, but it's fully JavaScript based, the actual plotting involved. And so it kind of behaves well. If you'll notice this, well, wherever it was, I guess it's already gone, so it's not behaving. Oh, there you go. So it's kind of some cross between a static renderer and something in a web browser. So it's great to have that, but bokeh takes the browser really seriously and does a good job of trying to make a nice plot. So you get that out of the box. All you did is replace .plot with .hvPlot, but then you do a lot more. Here let's try to fix the overplotting problem a little bit. So you can do that by changing the alpha parameter. There is no alpha parameter on here yet. So I guess I have to skip ahead to the solution and show you that. So you would just type that. So try that out. You can try it out any other So here alpha is setting the opacity. It's the inverse, the counterpart to transparency. So high opacity means low transparency. So if you take a low number of alpha, that means it's pretty transparent. And then you can start to see, oh, there are some places that occasionally have an earthquake, and there are some places that always have an earthquake going on. A lot of events. And so you can change this. You can change it to be really faint, and you would only see the most popular places to have earthquakes. Or 0.5, then didn't really help much. So you can kind of fiddle with it and see some more about the data. Okay, and this is a scatter plot. Scatter plot draws a point for every data point. Sure. And it was called scatter. So just think of any other type of plot you might want to do. Let's try a line plot. I bet it's going to look real bad. I don't think I've ever done that. So we can do this. If we press tab, I pressed the wrong tab. I'm out of it. Okay, so if I press tab here, you can see all the options that you have. You have area plots, bar plots, all sorts of stuff. Let's try line. And that line does not have that. It's probably going to complain about not having alpha. Okay, there's your line plot. This is basically connecting up every earthquake event. And that doesn't make any sense whatsoever, right? To connect up every earthquake with whatever earthquake happened to occur before it, unless there was some causal chain, and clearly it's not. So instead of line, let's try, I think it's suggested a hexbin plot. So let's see, hexbin plot. So that is a plot that will do binning on a hexagonal grid. And so it takes this visible area, and whenever an earthquake lands in it, it increases the count of that grid cell. And so you can hover over to see the actual counts. And you could say most grid cells, it looks like have counts between 1 and 10, 30, roughly. So they're down in this range here on the color bar. The color bar, most things are this cyan color here. And then occasionally you have some counts, 2,000, 3,000, 2,600. So that's California for you. And then you can compare those to the color bar, so 2,500. So this actually lets you kind of get a numerical feeling for the data here. Here you saw a picture of it, and you can sort of see some outlines of some shapes. And here you're able to kind of make sense of where the most common events are. And so where you have 2,000 here, there were 2,000 in this other plot as well. They're just all on top of each other. And you have no clue that that's happening. Make sense? So just so you know, if I showed you how to use the tab completion. You can also do help. You'll get all sorts of information. There are tons of things you can mess with for a scatter plot. You can color the points by some other column, like depth, and then there'd be a color bar for that instead of by the count, as in the hexbin. You can change all sorts of other things. So, but you'll need that for doing all the exercises in this course, but we won't go into it much now. And then I'll ignore that. Okay, so I mentioned this data shader library. I think the previous bits should be leading you directly to that. So data shader is enabled by turning on rasterize equal true, and it's very similar. It's basically the same idea as this hex bin plot. These are hex-shaped bins, 6-sided little areas that tile the space. Everything lands in some hex bin. Some of them are half cropped at the sides, but there are hex bins that cover this area. Data shader is not a hex bin, but a rectangular grid. What it does is take, for every pixel is a bin. So if 100 earthquakes landed in that pixel, that one would have a count of 100. The next pixel over, if only 2 landed there, that would have a count of 2. And here is that same 21,000 data points rasterized to screen resolution. So this is saying, the previous one was saying, give me a rough thing I can actually count these items. This approach is saying, show me all the data, as much as you can, on the resolution of my device. And if I zoom in, re-rasterize it for my new resolution. So there's always more resolution available. You can always zoom in and eventually see all the individual data points. But by default, you can see their counts. And you can see it's the same number of counts. So 2,200 of them landed in 1 pixel. The same pixel. Definitely do not move there, wherever that is. You can actually use Data Shader to find that pixel. You can Data Shader will return an array, and it's an Xarray type array. It's just like a NumPy array, but with some extra data. And so you can use it to do computations, like show me the worst place to move, and it'll tell you that. So, and this is using a, well, I'll get to that in a second, this color bar. But first, let's just go ahead and, instead of plotting the small data frame, because Data Shader doesn't care. Data Shader is doing all the work with very efficient Python routines. It doesn't care whether you have 2 million or 20 million or 200 million. So let's pass all 200 million of that data here. And so this is now all of your data. This is everything being displayed at once, but you notice the browser isn't crashing. There's no problem displaying 200 million data points, and that's because it's not displaying 200 million data points. It's displaying like 900 pixels by 700 pixels. That is multiply those two numbers together, it's far smaller than 200 million. So that's what Data Shader is doing. It's taking any enormous fire hose of data, eventually it becomes a picture that a human being is going to see on their monitor. So you can have petabytes of data. By the time you see it, it's just a picture. So only the little bits of that picture that are computed on the individual machines need to be sent from that machine down to your web browser. So that allows you to fully explore all of your data, hence the holo. So if you zoom in, you'll see it re-renders. You can see all the hotspots at all sorts of detail. So these are going to be modulated by little mountain ranges over there, geological features. If we overlay a map in a minute, you can see that relationship. But when you zoom out, you can immediately see, oh, that is a plate off the coast of Africa. I believe it's off the coast rather than on it. This is the coast of the US, Alaska, etc. Is that Hawaii? I don't know. Probably so. They have volcanoes, they must have earthquakes. Okay, and then when you hover, you can see the count per pixel. And so here, with this larger data set, you have counts in the 70,000s per pixel. So just imagine trying to plot little circles. Well, that would be 70,000 circles that you can't see. So the point of this kind of histogram-based approach is to start backwards from what a human being can experience. When you walk up, what do you see? You see pixels. Can we make those pixels pack in as much about the data to reveal as much about the data as you possibly can? And in the limit, just imagine that each of these pixels, like let's say it's this dark color here with several 100,000 pixel events in it. If I can hover over it, we'll get I had one that was, okay, so let's say it's got 20,000 earthquake events in it. You can see not only that there are those events, but then immediately you can zoom in and find what those events were. Here, again, we're not showing the category data, but we can. Okay, so it's trying to make as much as possible of your data available to your human eyeballs, subject to the limitations of your display device. Okay, at this point, if you've used Pandas, you should be able to realize, oh, I could do a bunch of Pandas stuff, visualize it, go back and forth between, oh, I only care about large events, or I only care about this range of latitudes and longitudes, or I want to filter by this and look at the combination of large and very deep, or large and very shallow, or whatever it is. You can subset the data. I'll leave that for you to try out. If you don't know Pandas, you'll first have to look up how to do that in Pandas. And to reiterate, these examples use Pandas, but the same API is available if you use Xarray, if you have n-dimensional arrays. It's also available if you use Dask. When I was saying petabytes of data on thousands of processors, that's with Dask. So Dask basically will run thousands of copies of Pandas. And then, so if you have a Dask data frame, it's really 1,000 Pandas data frames, and then Dask coordinates it, makes it look like it's one data frame. And same for a Dask array. So Dask is well supported by Xarray. So if you have an Xarray that's distributed, it'll support that. You can also have streaming data with the streams library. You can also start with data catalogs if you're a geoscientist. Stack data catalog is a good one. And then that'll immediately lead right to a Python data structure. You can work with GeoPandas, same .plot API, and then that gives you polygons like shapes of rivers or political boundaries. And it's somewhat similar API. It's pretty different because it's graphs. It doesn't follow the same structure, but it also supports graphs. So if you here are using the Pandas API, I'll just cut to the solution. If you know Pandas, you should be able to read this and come up with what to write. If you don't, it's something like this. So this is a Pandas expression saying I'm going to start with the data frame. I'm going to select only the rows where the magnitude is above 5. And then I'll go ahead and scatter plot it. And here we use data shader. You better be turning this on when you're working with your full data set. Because otherwise you're going to send 200 million data points to matplotlib and have to go out for coffee. And one last, and here we'd be setting the color map. So here we set the color map to reds. If we don't have that, it goes to the default blue. But more importantly here, this is what we call the color norm. If we take that out, that's pretty important. I need to explain that. So if we take that out, it'll use linear counts it'll use a linear color map. And, oh, sorry, I've only selected the magnitudes less than 5, so get rid of that. Go back to the original data set. Okay, so here I'm using the original data set with 200 million points and a linear color map. And so you can see that it goes from 0 count to some number. It steps up in, well, I'll just trust that it's linear. Actually, let's go ahead and specify that it's linear just in case. I think it's called linear. Yeah. Okay, so it's a linear ramp in count from count to color. So double the count, you'll go, so the value here will be half the count of right here. So that's linear. And you notice in this plot, you can't see any of that structure anymore. Why is that? It's because in California, there's that one place you don't want to live, and they have 50,000 earthquakes in that one pixel. And that's the top of your range. And then it goes all down to everywhere else in the world, which is colors like this, which is almost never has earthquakes. So this is why you don't want to, you normally don't want to use a linear color map, because data is not behaved well. You shouldn't count on your data being behaved well. It isn't going to be linearly distributed. It's almost certainly a distribution like this. It's a heavy tail distribution. If it's something like a magnitude or a frequency or an occurrence, there's a lot of cases where it's not linear. And so we have this color map that is called EQ-hist, that does histogram equalization and takes whatever the distribution is and it makes it linear. So it basically says, I want to see it, and I want to worry about how to interpret it later. So I want to see that there are some areas that are very dense, there are some areas that are much less dense, and I want to see that visually, and then I'm going to use hover to figure out the difference, the numerical values. But first I'm going to tell my eyeballs that there's structure there. Because if you just tell it linear, your eyeballs will not see the structure. You won't have a question. You won't wonder, what's going on over there? The downside to that, and we can get to that if we want, is that the very highest ones are just the very tall pixels, and then the next down is, it's basically like a, it's similar to a percentile plot. So the top 1% of the color map is the top 1% of the data, which means that if the tallest data point is 50 billion times taller than the next one, it's still just going to be one color different in the color map. So it's not going to show you. So I would recommend always doing both. Linear, and then at least if you have good eyes, I have glasses. If I put on my glasses, I can see some really dark data points over here. So you at least will see that, oh, there's something at the top of the color map range and everything else is down. But really you want to start out by seeing the full structure that's there at the risk of maybe you don't see that there's some crazy place. Okay? This is something for you to think about and wonder about, but it's something that just doesn't come up at all if you have a plot like this one. Right? You don't even think about how do you map from visual space to your brain space. Yes, on the right.
Me? Okay.
Okay, on the left.
How would you know when to treat something as an outlier versus a nonlinear space?
Here we're treating the data exploration problem as one of discovery. And so you want to first see the outlier and then ask exactly that question. That's a perfectly great question to ask. Are those spots, are they errors? I mean, are there really those areas in California that are too dangerous to live? And so you want to first discover that and then think about that. If you find that they're outliers, you can use advanced options to crop dynamically, ignore everything over 2000, let's say. That's a plotting option, so that after you render it, then you don't map from 0 to 50 million, you map from 0 to 70. And you ignore everything, oh, those are noise. Ah, that's because it's an industrial plant, there's something that's going pounding into the ground, sets off the seismographs all day long, every day, it's total noise, I understand it, I looked it up, I'm going to ignore it. You can do that. You can tell the plotting library, I'm going to ignore those outliers. Here's a good example. Well, actually, it's an example of half of that. If you go to the OSSIM example, it's the same type of plot. This is plotting OpenStreetMap coordinates for everybody's cell phone in a huge sample of people, so 1 billion of them. And you'll notice all this weird stuff here. I think that's something, that's a weird artifact. You can get rid of it by only looking at the pixels that have a count higher than 15. Look, it's gone. I literally have no idea what that is. It's in the shape of something that has to do with satellites. I have no idea this thing, but you can get rid of it. Just say only show the things that counts are above 15, because each one of these has only been hit once. So I decide that's an outlier, or that's a thing I'm going to figure out later. And then now I'm going to see a beautiful plot. So you can do that sort of math with your images with this approach. Yes?
Would that reappear again if you zoom in and it recalculates the counts for
Yep.
those regions?
Well, at that point, if you put a fixed threshold like this, as you zoom in, your plot will disappear because no point will be over 15. Because when there's 50 here, you zoom in and suddenly each pixel only has 5. You zoom in and suddenly each pixel only has 1. So this fixed threshold wouldn't work. You'd have to come up with a better algorithm for that. If you did, you can plug that algorithm in. Yes?
Why does the color bar disappear when you specify a color map?
Why does the color bar disappear? It shouldn't.
Go back to the tutorial. It literally happens. If you specify red.
Issue tracker.
Yeah, luckily these are real old versions, so that's probably fixed and you'll have new problems.
Where to go?
You can
Yeah. That is
Why is it not the default?
That's a good question.
that is a very good question. I have not noticed that, and I have no earthly idea. That's super weird. So, yeah, totally. You certainly don't want the color map to make your color bar disappear, and I can't even imagine the mechanics that achieve that. So, all right. All right, so you're spotting things that are not about the data per se, but about the plotting. That's the type of thing I'm always on the lookout for. But what I want, hopefully that you won't get sidetracked too much by those things. What we want you to do is really figure out stuff that's going on in your data and see it, explore it, understand it, and then publish in Nature or realize that your data's crap and start over. One of those. Okay. Just to sort of round out, and then we'll take a break after this. This is the heaviest duty plotting section, and then we need a break. At least I do. Let's just, we focused on scatter plots. None of these tools are specific to scatter plots, but it's super easy to understand a scatter plot. Data point, X and Y, put it there. And so it helps you understand what's going on. Let's look at some of the other options. Here's, looks like we've switched back to matplotlib. I don't remember doing that. Oh, because we did .plot instead of .hvplot. hvplot does support matplotlib, by the way. So it doesn't, you can either use the native matplotlib support or via hvplot. And if you use it via hvplot, you can use data shader and certain other things. It's complicated. I don't want to won't get into that. So here we are going to plot a histogram with 50 bins. This is using the native .plot support. So that 50 bins means find the count, find the length of this axis and then divide it into 50. So the, what are we plotting? By magnitude. So find the lowest magnitude, which is 0, the highest magnitude, which appears to be around 9, and then divide that space by 50, and then count and show it as a bar plot. This is the same thing that's happening in Data Shader, but it's doing it in 1 dimension here. Data Shader is doing it in 2 dimensions. Data Shader is not magic. It's very fast. It's highly optimized. It's well integrated, but it's not magic. By default, what it's doing is a 2-dimensional histogram. And here's a 1-dimensional histogram. And here's the same thing instead of .plot at hvplot. So this is just to emphasize, if you already know how to do it, you know how to do it in these tools. I assume that if you add rasterize here, it won't do anything. Data Shader is always 2-dimensional. It'll probably give you, yeah, it just ignores that. It's being rasterized anyway. Okay, and then you can do, this is a histogram. A kernel density estimate is a continuous approximation to a histogram. So if you see that this is .hist, and you know the abbreviation for kernel density estimation, you probably can guess how to do that. So I'm not going to look at the solution. I'll just plot it. And then when you do something like that, you have some chance that the options make no sense anymore. But in this case, I'll just keep them. They probably make sense. Nope. Oh, they don't, because it doesn't have bins. So let's get rid of the bins. And so there's your continuous approximation to this discrete histogram. And as mentioned, there are a lot of different plots you can choose. Okay, now we'll get a little bit, basically the data is not set up the way to do the type of plots we want to show, so let's make it be set up that way. Let's take depth and make it into a categorical instead of a numerical. That means, so 3 categories: shallow, intermediate, and deep. That's just Pandas stuff. So we specify those categories, which is the smallest value up to 70, that's shallow. 70 to 300 is intermediate. 300 and up depth is deep. And then we'll cut the data frame into those 3 categories. Basically, sort each data point by this into one of these categories. Okay, and that creates a new column, which for every data point, every row says which depth class it is. And then we put that back into the data frame. This is all Pandas stuff. You would do the similar operations, but different if it were an Xarray or a DAS structure or whatever data API you're doing. We won't teach you that, but assuming you can do that with your data frame or your data structure, then you'll end up with something you can plot. And then now we plot here. Now that we have this categorical, we needed that because we wanted to explain the by keyword. If you do a by keyword, it will do a histogram colored by the class. And that allows you to say that you can actually see there are not very many deep ones. So if we turn off these other ones, you could sort of, so the legends here are always live, well, almost always live, and that'll make them go away so you can see the deep, there are relatively few deep events, and they tend to be high magnitude. Now this is probably a limitation of the data, right? Why would deep ones be higher magnitude? Probably it's that when they're low magnitude you can't measure them. Again, I'm not an earthquake scientist, but I'm just saying, hey, why are there no low magnitude deep ones when there are so many shallow deep ones? My guess is that the magnitude, the lowest magnitudes are always more common. They're just not measurable for the very deep ones. I don't know how you'd validate that, but that's the sort of thing you can discover looking at this, so at least make a hypothesis there. And so hvPlot makes it super easy to do that. You can also make them facets. There's a subplots equals true option for that. Then you'll be able to see the deep ones separate from the others. And if you notice the deep one's now very small, that's because these are all on the same y-axis. If you don't want that, you can use the ops system. We'll get to that. But what is the option for that? I think it's frameways equals true. No. Axis one. I can never remember them. I always try all combinations. That should be setting the, I don't know why I went off in that tangent, that there should be an option to set the normalization so that happens independently per axis. This is one axis. There's also an option there. So the axes can be shared and they can also be normalized. These are two different concepts. Axes. Oh, okay. Yeah, so, and that's another, so this is a digression, I may as well put it here. hvPlot gives you a HoloViz object. HoloViz has an ops system. hvPlot is the Pandas API, and so it's respecting all the keywords that Pandas had, whatever they were, and then it's translating to the appropriate call for bokeh, the appropriate call from output.lib. But whatever it does, it creates a HoloViz object, and at that point you can further customize it if you want. That's what I was doing here. So ignore that. This is an hvPlot option that is understood directly by hvPlot and is not delegated to this underlying library. Usually you can forget about the underlying library. Sometimes you say, how do I change that? And you have to go look at the underlying library. So thanks, Scott. And so having this option allows you to see the shape of them, but now you better really pay attention to these numbers. 4e to the 5th, 40k, and 8k. So this allows you to see the shapes of the distribution, but it's obscured the fact that they are very, very different in their counts. So this is exactly what you ought to be doing when you're using these tools to explore your stuff. Try it both ways. And normalize them together, normalize them apart. See the shape, see the magnitudes. We did the same thing with data shader. See the range, see the distribution. Do everything. This is just a slightly different type of plot where it's plotting magnitude versus depth and showing that for the shallow events, there's a sort of sweet spot of common, typically around magnitude 1 and at a certain depth. I guess you have to not totally be on the surface because there's nothing going on there. You have to be, but you can't be so deep that you don't measure it. So, all right, and then notice we have this widget here. This is magic. Why did we suddenly get some widgets? Oh no. We got widgets because we specified not by, which is very confusing, but group by. Instead of coloring by is not quite coloring, but it looks like coloring. And I'm just going to confuse you if I tried to explain that. But group by is definitely clear. Group by says, give me a widget grouped by the value of this column. So if the column has 3 values in it, shallow, intermediate, and deep, you end up with a widget that has those 3 values, and you can select that, and then you'll see what's going on for intermediate. You'll see what goes on for deep. What goes on for deep is weird. Any earthquake scientists in the audience? Why is deep like that? Hypothesis. Explore that. But you can easily see that if you don't. But if you collapse across all depths, you don't see that structure at all. So it's only when you separate it out by the depth, you can see weird stuff going on depending on the depth. So again, this is your process of exploration. We, as tool authors, want it to be super easy for you to explore like this and think, is this variable important? Ah, it's not. Collapse on it. It is? Oh, expand it. Interactively zoom in, look at all the different combinations, lay them out all side by side so you can look at them, use color, whatever it takes to help you understand this data set. That's what we're here to support. If it doesn't support, file an issue request. If you say, well, how do I do that? Well, actually, we have a discourse forum, so that's where you'd ask a question like that. Issue, so a GitHub issue would be for bugs or for very concrete feature requests. If you really just, I don't know how to do this, is there a way that we have the discourse forum for that? Yes?
Can we do a rasterized image on this? We're looking at a pretty small fraction.
The rasterize, well, let's see what rasterize does here. It doesn't do much because it's already been, what rasterize is doing is rasterizing this line. So the data set has been reduced to these contours. Ian, wherever he was, I think he needed to go to Bokeh, implemented a lot of the contour support. So rasterize is taking that line. If you zoom in, you can see that it's that. So rasterize doesn't do that much useful, but if you don't do a bivariate plot and you just do a scatter plot, which I think is the default, maybe not. If you do a scatter plot, then you can do a scatter plot by depth versus magnitude, and so maybe that's what you're after. And if you and it's grouped by depth class. If you take out the group by. So all of these things are meant to be combinatorial. Now, you'll always find some combination that breaks. But they're meant to be mix and match and be orthogonal to each other. So here, if I just take this is just a plot of depth versus magnitude, and then I zoom in specifically on this axis, because I want to really see what's going on. It's pretty light. Oh, I need to do EQ Hest. I could type. All right, so now if I zoom in here on, if you use the zoom tool on an axis, it'll zoom only on that axis, and then you can see what's going on here. So immediately you can see things that, like Michael mentioned, are these artifacts? Like, notice all these vertical lines here. Is that because Mother Nature is resonant? Or because people truncate their measurements, or it's rounded, or there's some agreed protocol for binning. If you had a coarse resolution, you would have no idea that's going on. Data shade the heck out of the thing. Just show it all. And then you'll see all this stuff. And then later you decide to ignore that. Oh, okay, I better blur this horizontally because my data has actually been pre-binned for me. Ah, why did they do that? But okay. But at least you can see that that's been happening. There are these special values. Maybe they're integer. No, not quite integer. What are they? 1.1, 1.2. Okay, there. Looks like people love one significant digit after the decimal one. So I call it that. Okay. And then some other crowd is a little bit more precise, and they categorize it that way. And if you zoom in, there's probably some that are in between them. Or you can do that bivariate plot that just ignores all of that and gives you a shape. What are you asking for? And a lot of the times it's, do I want to focus on noise? Do I want to focus on the distribution? Should be super easy to switch back and forth and just explore. These are all one-liners, by the way. This is all meant to be, I want this, you have it. I want this, you have it, and you try to go back and forth, and you have this whole process. Like, you don't walk up saying, I want to make a scatter plot. You walk up saying, what is my data? How can I understand it? Do I need to look at this way? Do I need to dice it, slice it, whatever? That's what these tools are for. So, you can classify magnitude. I'm not going to get into that. You can get a, but if you do that, then you have a doubly categorical plot. It's classifying by magnitude is exactly the same as classifying by depth. You just bin it and get classes out of it, and then here we plot the magnitude versus the depth. Here, this is the super coarse version of this plot. Magnitude versus depth. Do you want this plot? Or do you want this plot? We support them all. What is your question? Do you want to find the range where things are going on that you care about? Do you want to find the problems in your data? Do you want to find the details? We don't know. It's all up to you. Okay, to finally wrap this up, those were bokeh-based plots. Here's a plotly-based plot. You just select this command called .extension. The default is bokeh, but if you want to select, you can enable plotly and matplotlib from hvPlot. Remember, hvPlot is built on top of what I would consider a visualization library. It's a data exploration library, really. And so it's, it doesn't have a strong opinion of which library you use. The best support is for bokeh. For interactive plots, best support for publications is for matplotlib. For really snazzy print output, matplotlib is your friend for as a plotting backend. And Plotly, there are certain plotting types, particularly 3D plotting types that bokeh doesn't have. That's when I would switch to Plotly. But you can choose whatever you like. If you just like the look of it, sure. And then you can, here we selected matplotlib. Sorry, just to clarify, this declares which ones are available, not which ones are selected. By default, it selects the first one. If you want to select some different one, you have this command called output. You select whichever output. It has to have been declared because that loads a bunch of support. And then once you've declared it, then for any cell you can choose, you can change that all the time. Here it's a matplotlib plot. And so therefore an image. And then you can do then you can export that to SVG, which is what you should do for a nice publication. Here we saved it to SVG and we brought it back in. Now this is not a PNG, it should be a SVG. Should update, maybe that's, doesn't look like it's updating. Anyway, it should be, it was saved to an SVG and reloaded. Oh, sorry, that's why. That was the PNG. That's why it was behaving like a PNG. This one should behave like an SVG. Aha, there you go. It's still sharp when you zoom in. That's why you want SVGs for your publications. And then to mention that you don't get into a dead end here, you just, these are designed to make it super easy to explore, but then what happens? then you can always get back the underlying matplotlib figure or bokeh figure and do whatever you want with it. In this case, we got back the, we call this render command to turn it into a matplotlib figure. This is like any other matplotlib figure that if you did it by hand. And as soon as you have it, you can do things like change its style to be XKCD style plot. Sure, you can do anything you can do. HoloViz has no support for that. hvPlot has no support for that. But once you get the matplotlib figure, you can do what you like. The same with bokeh. Once you get that, you can mess with any bit of the bokeh plot. So if you need to, don't do it during exploration. But if you want to make a point in a slide, if you want to tweak your figure for publication, that's always available to you. Okay, well that was a marathon of pontificating about plotting, and I hope that it achieved conveying that these tools are a little different from just a plotting library. They're really support for at your fingertips for understanding your data, for visualizing it, for interacting with it, for just coming to terms with it. And then as soon as you've done that, then we'll quit from this notebook and we'll move on to another notebook, which is about sharing it. So assuming you've made your discovery or you've found your fatal flaw, then you start communicating it. But I will take a few-minute break here. There's more plotting material, but I will go quickly through that. And those are things to return to, because those are not fundamental deep issues. They tell you how to do things you probably want to do. So you need that. I'll show you that, but I won't linger at it. Yes?
If I have a matplotlib figure and I'm using the HoloViz visualization, do I still get the performance enhancements for displaying market, etc.?
Yes. So the pipeline, I'll show you the pipeline. So if you go to datashader.org, there'll be, there should be a getting started. Oh, it's over here. Okay, there's a pipeline. So it starts with your data. Now here it's all in one. In this picture, the data is as one coherent thing. But that data can be distributed across many processors. And on each processor, it converts the data. You have to choose what you want to plot on X and Y. That gets you to this next stage. Then nothing has happened. You just sort of declared what you're doing. Then you aggregate over that. That happens independently per processor. And then you transform it, like you cut off all the ones over 15, or you scale it, histogram equalize, or whatever you want to do. Do some sort of optional transformation. And then in this version of it, you map it to a color, and then you feed that to the plotting library. So if the plotting library, matplotlib or plotly or bokeh, they all come in at the last stage here. So you will have done 1,000 different chunks, well, 1,000 different PNGs in the limit. If you're rendering all the way to PNG, which is one option, then you end up with 1,000 PNGs. Those 1,000 PNGs are sent to one server that you're talking to. That server puts 1,000 PNGs and gives you a big PNG, renders it with matplotlib, and well, it's rendered individually as a PNG, put it together with matplotlib with axes, and that becomes a big PNG, and that big PNG goes down to your browser. That make sense? The other way you can do it is to flip those around, and that's, with bokeh, that's the usual way to do it, is you aggregate it, and you hand this array to bokeh. And that way, when you hover, you can see the counts, rather than you hover and you see an RGB value. So we strongly recommend that. I've been showing the rasterize option. There's also a datashader option that corresponds to this pipeline, where a datashader is in charge of rendering all the way to an image. And only at the last stage is it embedded in a plot. And we like to recommend don't do that. Wherever it's supported, hand as much data down to your local browser as you can, as long as that's not going to overwhelm it. And handing an array is no more data than handing a color map image. So may as well, but it takes a lot of work for us to support that at bokeh. We don't support it in Plotly. We don't support having the full hover information available in Plotly. So for matplotlib, there's no hover, so it doesn't matter. Okay. Any other questions? All right, so I'll give you 5 minutes. If you need something to do, you can scroll back to the things I skipped and try out the options. I strongly recommend trying out the help at least. Go through the help and understand what's available in the help. And it says in there how to get to the help. So try those out. Check your email if you'd rather. Just give your brain a break. I'll be back in 5 minutes, which is 9:35. Okay, well, hopefully everybody's brains can absorb new information. Someone reminded me I should mention hvPlot Explorer. It is not integrated into this tutorial, but if you don't want to type, you can just do hvPlot Explorer in your data frame and then select what type of plot you want. It's a great way to learn what the options are. Select what you want to be on the X and Y axes. Select by and group by. These are all the things I showed you how to do in Python. You can do it with widgets. You just open an hvPlot Explorer, and then it's got the handy result that you can get it back as a set of settings, and then that converts it into a Python data structure, and then you go back and get the plot. So if you selected this plot in the using the Explorer, then you can get some Python code that'll always reproduce that particular plot. And so the hvPlot Explorer is a great way for the things it supports. It's a super easy way to explore your data set without using Python. But I would never stop there, because then you would have to recreate all of the widgets that you had used to get there before. So don't walk away without capturing it as Python. Python is always going to come back to you and be able to reproduce the thing. But it's a great way to get to a set of Python that effectively you can just see that this is essentially keyword arguments for the call. So you just take those keyword arguments and you put them here. So you explore it and then get some settings, or even get the code, I think, whatever it says here. So, and I have no idea. The version that's in the tutorial is older, but I don't remember when the Explorer was introduced. So it may or may not be in the tutorial environment that you have. It will be in any new installation of hvPlot. It's been around for a while. I just don't remember how long. Okay, so back to the tutorial. Again, I said I would spend less time on these because they're important, but they're not going to challenge your notions of what a plotting library is, hopefully. Well, maybe a little bit. So let's get into it. Again, if I get bogged down, remind me. I should try to not. In fact, I'm going to use restart and run all so that I won't get bogged down. How's that? So I'm not doing it step by step. Okay, again, we're going to read in a bunch of data points of earthquakes. We will resample the time axis a little bit because it just makes it easier to plot. Those are Pandas options. You can study them. Note that we created a, quote, plot. So here we called hvPlot and then we assigned it to a variable. This is an important concept. What is this variable here? If you display it, it's a plot. But what is it really? It's really a HoloViz object that is a curve with independent axis time and dependent axis count. So I lied to you. There are super important things here. So this is a plot that has these key dimensions, we call them. You can also think of them as independent variables and dependent variables. You can also think of it as X and Y. But you can have any number of these Y variables, and if you have more than one independent variable, if you have two, that would be like a heat map or a scatter plot. Here there's only one, so it's a single independent variable and multiple dependent variables. And so here we are showing that this, quote, plot object has this stuff in it, but we can actually we'll get to that in just a second. First, let's get another plot, and then we'll demonstrate a pretty easy concept to understand, the concept of overlay. So we got this thing that if displayed is a plot, and we got this other thing that if displayed is a plot, and we have this operator here that combines those two things, and then it gets displayed as a plot. Now, normally you can't take a plot and another plot and put them on top of each other. But instead, you're taking this data structure. So what is this data structure? It's a lazy data structure that is an overlay of two things that, if displayed, are curves. I'm being very careful in how I'm saying that. It's not an overlay of two curves, because they're not, I mean, it's curve objects in Python, but they haven't been plotted yet. It is just the data that if you wanted to plot it, that's how it would show up. And it's key that it has not been plotted yet, because that allows us to overlay it and do anything we want. We can overlay it and plot it, sure. We can, that's what this operator is, star. There's another operator that's plus that will lay it out next to each other, either left to right or top to bottom. So these are the two underlying bits of data. Notice that when it got combined, the colors are different so that you can distinguish them. These are all the things that you want to do, but hvPlot and HoloViz are taking care of them for you. And so, of course, if they're in the same plot, you better have them different colors. So when they're in the same plot, it uses a color key, a color cycle, takes the first color and assigns it to the first plot, the second color to the second. You can define that color cycle if you want. But by default, it just chooses some unique colors according to this list of colors. And however many things you're overlaying, that's how many different colors you get. And if you're laying them out next to each other, well, they don't need to have different colors because they're in a different plot. It knows all of that. Now, you can always override it, and that was my point before. If you just accept what it does, you can get on with your life in a very small number of lines of code and be very flexible and not dig a deep hole into something. If you really have a strong opinion, you can customize everything. If you want these both to have the same color, totally easy. You just set them to the same color, sure. But usually you wouldn't, right? It tries to do what you usually wouldn't, usually want it to do. And then here, let's just see what this object is. The previous one was an overlay. This one is a displays as things next to each other, but what it is a HoloViz object called a layout of two curves. And so if we take that, we can assign that to a variable if we want. Let's call it layout. And then if we want to display that, we can. Or if we want to print that, we can. Or if we want to pull out one of these curves, we can. And then that would be curve dot. That would be a curve. So we've selected one of the things in the layout, and then we just get it back. Now we can display that as a plot. That make sense? So basically, anything you're displaying is a not yet a plot until the very last step, right as you've exited from the Jupyter cell. At that point, it checks, hey, do I need to display this? Oh, I do. Look at that. I'm going to display this thing. Until that very instant, it is not a plot. It is a data structure that has data annotated with some metadata that says this is a curve, not a set of points. It has this title, these options that will be applied when I render it to a plot. So I did say you weren't going to get big new ideas. This is a big new idea. So that's why this takes 4 hours. So the thing that hvPlot gave you looks like a plot. It acts like a plot, but it is so much more because then you can combine them. You can overlay two and lay those out next to others. And then you made this massive 17-part figure, you can always pull it back out. And you can even get the data. What's it called? Data? I forget. Yeah, you can get the data back out. So it's just some annotated data that looks like a plot, right? It's a plot. Well, one of these is a plot. After I've picked a particular one, it's a plot, but it's not. It's annotated data that is always accessible. And so if where this came about is that I was a professor. I was doing neuroscience. We have simulator, and we wanted to return an object that looks like a plot, but is not a dead end. We wanted to always, oh, I see that plot. What are those data points? I always wanted to pull out those data points. So it's always returning a lazy data structure that looks like a plot. Oh, yeah, it's a plotting library. It's not a plotting library. It's a data exploration tool, like I said, and it's a data structure for annotating things that are visual. Back to my point earlier, everything should be visual all the time, or it's totally going to sneak past you that it's got bugs, got errors, or you're going to lose you're not going to notice the discoveries that you could have. So that's a big deal. These objects, whatever you got back from hvPlot, can always be overlaid, can always be laid out, or overlaid then laid out, and overlaid and laid out to make a complicated plot. And at some point, these little pluses and stars, you're going to get tired of them. You really want to have lots of control about how many pixels wide this thing is, and set it up here and divide it in this way. The panel library I mentioned earlier, that's where you do things like that. But for just a basic research, you just say, oh, I want them to overlay, or I want them laid out side by side, and you can also change the size. Like, that'll look really bad, and go ahead and display it. But we probably have to do it on the individual plot. Yeah. Okay, change the width of this particular one. You can always mess with things, but at some point you're going to want to really just design your whole page. That's for the panel library. This is hvPlot level. Okay, scanning through just to look for any important things that I have to tell you. I'm trying to be fast. Here's one that has two dependent dimensions. So this high magnitude scatter plot, it's colored by magnitude. That C means color, so it's got X, it's got Y, and then this third is not count like it was before in the data share plots. It's a scatter plot again, and the color doesn't mean how many are overlaid. It's the color of that particular data point magnitude. So this one is 7.8. The color of that pixel should be this color here. That make sense? So we've colored by that. And when we've done that, we have two, actually this is an error. I'm about to explain that. This should say, and it'll show you in a second, it should say that there are two independent dimensions, latitude and longitude. Those are equivalent. There's no special value for latitude versus longitude, right? Those are two independent dimensions. The location of that earthquake was somewhere on the globe. But this is actually showing you that the plot looks fine, but it's wrong because it's saying there's one independent dimension and two dependent dimensions. That is wrong. And the reason it's wrong is that the scatter plot in Pandas API defaulted to thinking that there's one dimension and everything else is scatter. But we can do better than that. We actually have it looks the same, but it is a points plot, not a scatter plot. And a points plot is two dimensions. There we go. I rediscover this tutorial every time I look at it. But this is a points plot with two key dimensions, two independent dimensions, latitude and longitude, and one dependent dimension, which is the magnitude at that location. Make sense? Maybe not. It looks the same, right? It matters if you're indexing in it and you're taking a chunk out of it and you're analyzing and you're trying to work with it. It matters which dimensions are ones that you are indexing and which ones have values. Index is something you put in. You decide which index to look for. The value is what was measured at that index. This is just showing you how to work with different colors. And here we added I mentioned earlier you could control what goes into the hover. Here's how we do that. Hover calls argument and say we want the place and the time. Those are the things you kind of want to know. What is this thing? And There's Mexico, Guatemala, etc. Hey, those weren't even California. All along down into South America. And so you can see the time of it and the location. Okay? And then once you've done that, now look at this representation. Now you had your data frame. What have you captured and put in this plot? It is a plot of points, latitude and longitude, and you've got 3 dimensions. You've got the magnitude, that's shown as color. Let's go back to this. You've got the magnitude shown as color, and you've got 2 more dimensions that are shown as hover. So that's another kind of deep thing to think about. You've got all these dimensions available. You've measured all the things about everything. How much do you want to choose to show to your viewer, your user, yourself? You get to decide that, and you think about that, and you really think, okay, what do I care about? Do I care about magnitude? If you care about magnitude, make it visible. If you're also interested in the place and time, once you've noticed something about the magnitude, then you put that into the hover. Does that make sense? You need to put what you want to notice in the visible bit and what you want to find out later in the hover bit, because the hover is only available once you've noticed it. What is that thing? Oh, that's the northern mid-Atlantic. Oh, okay. But you'd better make it be the thing that you map something to the visual screen that is the thing you care about. And so it's designed to make it easy to choose what things you want to display and what things you want to find out. Okay, I mentioned maps. This is the part that's tied to geoscience, but only very weakly, because pretty much every science happens somewhere. And you might even want to just display your research lab versus somebody else's. You might want to put that on a map, even if you're doing nothing to do with geoscience. So HoloViz includes very basic support of that nature, basic how things relate to each other on a flattened view of the Earth. Anything more than that, go to GeoViews. But HoloViz has tile sources. If you're not aware of how they work, like Google Maps, if you're zoomed way out, you'll see just a single tile. And you zoom in, it's going to get a chunk and a chunk and a chunk and put it together and put it and show it to you. And so that way, like here, if you wait for slow, you see it filled in. It's almost exactly like data shader. You zoom in, the detail isn't available, you make a request to the server gives you the results in tiles, the client puts them together, and then you get a picture. That's called a tiled web map source, and they're ubiquitous. That's how all the mapping tools work, and so they're easy to display alongside anything else. Here, we can take that tile and overlay this data points on top of it. All right, so look, that's got a lot of stuff going on in Central America. So do move to California. Okay. That's the sort of thing you want to put context in, right? You want to know that not just the general shape, but the very precise relationship to another data set, in this case, the satellite imagery data set that was used to create the map tile. So you can do this. There's also a shortcut, which is here. You can just pass in tiles and then the name of a tile source. So here, this is a tile source of satellite imagery. There are lots of them available. If you look at GeoViews, you can see, or somewhere in HoloViz even, there's a page full of a dozen or so. You can have street outlines, street names, place names, just water versus land, whatever you want. Anything like that, you can just choose to say it. Typically, we'll use the physical features like this. Okay.
Can I make a comment?
Yes, please.
If you specify in those maps, you then specify options and width. If you like maybe leave it as little as 800,
Mm-hmm.
you can have multiples of your map.
That's right.
It's not really.
So here, if I zoom out, look at the multiples of the map. It's horrible. Oh, it's offensive. But you only have one copy of your data. And that's just We had some bokeh devs here. They ran off that way. They're going to have their own tutorial. You can talk to them about that. This is how bokeh behaves. The reason it does that is that is for boundary effects. Like, do you want to see the world like that? Maybe, but maybe you want to see the world like that. And if your data is over here, the map tile source doesn't really care. Like, well, I don't care where the start and end it's a circle. Where do you want it to start and end? I don't care. So that's the decision the bokeh devs said, well, we're not going to have an opinion about where this starts and ends. Whatever data, if you choose data that goes from 0 to 180, we'll take it. 0 to 360, great. Minus 180 to plus 180, great. We'll do it all, whatever it is. And then when you zoom out, it's going to look really weird. You could have maybe an option to crop it just to the data that's there. That'd be weird. All the options are bad. Fundamentally, you're trying to map a sphere onto a plane, and it's just bad. Yes?
So how would it be fairly straightforward to modify this plot so that the scatter points showed on every tile?
I don't know that bokeh has an option to do that itself. I don't think it does. You'd have to copy the data, and every time you do it, you'd copy it. And you might want to do it twice, because that way you can have any subset of the world, and it would cover everything. To do it infinitely requires infinite number of copies, and that would require a bokeh solution. Yes?
How about lines that wrap around the date boundary, or wherever you wrap?
It works. So it does something. You need to be careful what plot you choose for that scenario, because that's right. So if you are connecting these points, these are not connected, and you want to connect to one, like the path of a ship that goes here and then goes over here, you need to define what happens there. And one thing you can do is to break all those lines at the boundary. That's what I would normally do. You have to do that at the data level. It is tedious. And that's the sort of thing that bokeh can have help with. If it were aliasing the data everywhere, it would automatically do that, and so on. Yes? Yes? I don't think it's any different at that. What GeoViews does is allow you not to have, this is one projection, the one projection that's supported by HoloViz, the Web Mercator projection. GeoViews supports any projection, so you have ones that look like spheres, you have ones that look like donuts, whatever mapping you want to have from the sphere to the plane, and it does those calculations dynamically. This thing, you have to previously project it into this easting-northing space, and then it will show up on this map. And I do that this way. It's the one thing that just works, and it's fine. Anything else you pull in GeoViews, but it doesn't do anything magic. It just does data points get projected before they're displayed. So it's one transformation step that it adds. And it does that with these compiled legacy tools that are very solid and very established, but they're not Python, and there are all sorts of troubles getting them to work in your Python environment. So if you need that, great. If not, don't worry about it. Okay. We've only shown a few types of data. Let's go ahead and make a raster plot so that we can compare. It kind of touches on the things that are different about Xarray versus Pandas. Both of them are built on NumPy, but they make sort of different assumptions about what the shape of your data is. Here, let's get some data as an Xarray. And this is to answer a question about which earthquakes might affect humans. So if you're a very human-centric person and you care about people, you probably want to think about which ones will be nearer to population centers. And so let's bring that in. So that's again one of the points of really making it easy to bring in all sorts of data of all different dimensionalities, all different sources, and get it in front of you as a human being to understand. So let's get some population density in here and compare it. If we just plot that for a particular little range, I don't even know what that is. I don't know where that is. I don't recognize it. But the reason it's zoomed way in here is that matplotlib struggles with plotting the entire data set. If you just use the .plot API, But if you use it via hvPlot and you rasterize, then it should be able to handle it. So that's what we do here. We turned on rasterize. We used hvPlot. We chose a log instead of linear. You can do linear. If you do linear, you'll see that most places either have data or don't. And then there are a few places that are very, very dense. And you don't really get much, you don't learn much about how the world is structured. But if you use a log or EQHist, both of them look about the same. I think log looks a little better here. Both of them show you a lot of structure. So they show that people live where rainfall happens. You could actually overlay a plot of rainfall here, and you can see the population density in America matches exactly the rainfall map. Nobody lives over here in these mountainous, deserty areas. Well, obviously, well, Scott does, but occasionally people live over there. You can see little spots, but mostly people are really densely populated. All this fertile farmland here supports a lot of life. And so on. So you can see all sorts of detail in the in this rasterized image, and if it's not enough detail, it'll re-rasterize when you zoom in. So where do people live in Britain, where I used to live? I used to live right there in the population center, London, etc. So at some point you'll reach the limit of the data set, which is about here. It's on a grid of, I don't know how many meters, but it's not infinitely. It doesn't have a point per person. This is rasterized, pre-rasterized when I got it. So this is actually originally point data, if you think about it that way. It's been pre-data shaded because people are individuals, right? Population density, that's not even a thing. That's a mathematical construct. It's an abstraction. It's been pre-abstracted when you got this data. I prefer to work with the original data, the actual locations of every human on the planet. That's what I want to see. But this is an approximation to that, and you can see the limits to that approximation when you zoom in. And it's fine. When you zoomed out, it's the same as if it were a data shader plot of all the individuals. It's equivalent, and that's really how you should think of the data shader plot. It's a density plot. It's a histogram by pixel of how many people are in that plot, in that pixel. All right. Curveball number 74. If we look at this image here, this quote image, oh, it's already here. It's not really an image. It's what's called a dynamic map, and that's all that means is that there's some index, which in this case is indexed by the spatial extent of the plot, so that whenever you zoom in, you'll see the index, the spatial extent has changed. It's a dynamically updated image. It returns an image, but which image? It's one that's been selected by essentially an X range and a Y range. So you'll have to think about that, but it's if it's not a dynamic map, you can turn dynamic equals false. It'll look the same. And then when you zoom in, nothing happens. So that's what dynamic means. And you look at the type of that guy, it's just an image. So if you're not dynamic, it is what it looks like. But if it's dynamic, there's some variable that it's respecting. It might be a widget, it might be an interaction, it might be a tap, it might be a zoom event in this case. There's something that's dynamically determining what you see. So it's not an image, it's a map of images. So dynamic equals true. This is all HoloViz level concepts that show up in hvPlot. It is allowing you to dynamically reconfigure. In this case, it's implicit. It's rasterized is what is determining it. But a group by would also determine it. You know, lots of things can give you a new image based on some sort of input. So that's a curveball, whatever number. If it's dynamic, it'll be interacting with you in some way, and it'll be updating it. In the end, though, it'll be an image. That is what's, in this case, it'll be an image. If it's not, you do some other plot, it won't be an image. It'll be a line plot or whatever. Okay. All right. Okay, we're trying to build up to this idea of an app And I want to motivate the app that we're building up to as, calm down for a second. You have a multidimensional data space that's very abstract, and you're giving users windows into that multidimensional data space. A particular plot is a window into X number of dimensions. 1, 2, population density, that's 3. Magnitude, I think that is what it's showing here. Yeah, it's plot of magnitude here, that's 4. Hover, that gives you 5 and 6. You have all this data available, and your job is to communicate to either yourself or another human being. And when you're building a dashboard or you're building a figure in a paper, your job is to take this abstract multidimensional space and fit it on a page or fit it on a monitor with widgets so that a human being can appreciate it. Humans can't just walk up and appreciate multidimensional space, right? But that's your job as a data visualizer or a app builder. Most people don't think about it that way. My job is to turn multidimensional space, essentially linearize it, not quite linearize, like spatialize it, make it be something that eyeballs can understand. But that's really what you're doing. You're taking multiple data sets here, you're showing the relationships between these different dimensions. These population dimension here, there's not even a map anymore, but where people live happens to be where there's land. So it works like a map. And so you're showing a relationship between the places on the planet that are inhabited and the places that have earthquakes. Those are links between different dimensions. Those are like, why should places people live also have earthquakes? Because they kind of look fun and they make nice coastlines. People like to live on the coast. There's a relationship, there's a correlation there. This is not an accident that earthquakes happen along this. It's like people like to live on the coast. There are fish there. They're swimming there. There's pools. Whatever. Does that make sense? So you take some abstract data that's in some files, and you're going to turn it into something for humans to consume and understand and work with. And as simple as overlaying can show the relationships between totally different sets of data and make you think, why are they related? Why does that follow that coastline? And so on. And then what's going on over here? Oh, well, a lot of earthquakes, and they're making a bunch of islands. Those are areas of geologic activity. Stuff happened. It crops out. Now somebody can live on it. If it didn't pop up, nobody could live on it. Like, oh, interesting. Anyway, that's the sort of thinking that you're trying to lead towards, that turn numbers into some appreciation for all the interactions across all these different dimensions. And what did we cram into this plot? Well, we print it and we see what we crammed into it. It's got a dynamic map based on ranges. It doesn't show you, I don't know why, it ought to show you what's triggering the dynamic map. It's something called streams. We'll worry about that. There are streams of data coming in this case, range event streams. And that's triggering to return an overlay of an image and some points. Going back to the plot, this is an image with some points overlaid, and it is updated when I zoom in. Okay? So you go back and forth between just some data and some visualizations of the data, and really gets to start to tell a story, show a relationship, show what you're trying to do here, and without ending up in dead ends. So this thing here, we can always pull that image out. You work with it a day in and day out. This is your standard plot all the time, but you want to say, what's the number here? You can always get to that number. You want to pull out that data point? You can always get to that data point. So. Okay, and I have a cute little thing that says, the always getting to stuff is about shortcut, not dead ends. If you want to if you're here and you want to get exactly right here, you can use low-level tools and you choose this, make a choice, make a choice, make a choice, learn about this, figure this out, don't go that way, go this way, don't go down that, no, no, no. You learn everything, you can get everywhere. This is going to take you a long time with a low-level tool, or you can have a high-level tool that gives you 3 options. I want A, B, or C. Oh, I love C. Done. What if you don't love C? What if you almost love C? That is where everyone's always is. They want to have, oh, I just want C except. Well, that's what these tools are all designed about, this principle. I just want C except. You learn this neighborhood. You look up the options. Like, what are the options? I wanted to change the color of that. I want it to be bigger. I want it to go behind that thing, not in front of that thing. You learn about that thing, and you ignore all the rest of the space. You don't have to worry about the rest of that. So that's the fundamental principle of all these tools. And you have to counteract that with, they've become complex. It's got bokeh with data shader, with HoloViz, with hvPlot. That's a lot of layers, so it's a complex system. Most of the time you can surf at that top layer. You only have to learn the things that you care about. That's this idea. Or you learn just a little bit of the low-level stuff at the next level. Oh, you had to go, you go down one level. Oh, you got to go to the raw bokeh. Oh, you got to go down to the CSS? Okay, you do that. You do that for your boss or for your publication. You do that rarely, hopefully, or else there's no reason to use these tools. If you're doing it all day long, well, live there. Live there. Learn all of that. Be an HTML front-end engineer with JavaScript and CSS. Live there. Totally. Go away, though. You're not our audience. We are not helping you. You can do your own stuff. We're helping you to do this. We're going to try to have high-level concepts that map to what you need to do as a researcher, as an analyst, and then also not box you in so that you just can't get there, but to give you a way to do it with a little bit of work. So that's philosophical, but it drives us to work every day. That's what we try to do. Okay, that's composing. This one surely is quick, right? This one should be no problem. Let's see. So composing was about, you've got all these things that you individually could see, either put together in one plot, put them side by side, or some combination of that. But what if you want to control how they link to each other? Because you really want to understand, if you say this data point, is it this data point over here, this one here? How do you connect things up to say that this thing that really stands out to you, does it also stand out in these dimensions, or is it really tall, but also really dark? Which is it? Like, how do you relate all of these different dimensions to each other? HoloViz and these tools are built at a higher level that allows you to express that. Again, it's not a plot. The actual real data is there, and you can work with it directly. And so let's work with it. Here, let's just demonstrate something. These two plots are laid out side by side, just like in before, but now they are what's called linked for selections. This is a concept called linked brushing. So that if I want to select the particular, well, I need a square, where's that one? No, this one. If I select a certain range of magnitudes, how do those relate to the depth? So actually, let me reset that. So what is this big thing here? If I select that range of depths, only the shallowest depths, how does that relate to magnitude? Oh, it looks like at the lowest depths, it's got a reasonable full range of magnitudes. Okay, well, that's sort of a null hypothesis. Looks like if I select the lowest depths, it doesn't affect magnitude. What if I select the highest depths? And then maybe zoom in here. So you can see stuff. Well, maybe that didn't affect much either. But you can see how it relates anyway. If the deepest depths were always a certain magnitude, you would be able to explore that and see that. Let's see, what it says here is select deepest ones. They're not specific. Oh, okay, it's just showing what I just discovered again. It's saying that. I was thinking it was going to tell me there was some cool relationship, but it doesn't. I mean, I wrote that, but I wrote it, some other version of myself wrote it. But kind of more importantly than the histogram with each other is that you can relate totally different types of data this way. So here, if I want to see only the distributions across South America, now you can see the full distributions in the background, and the distribution across South America is now there. By the way, these are called bokeh tools. Often you don't worry about it and things just work, but if you need it to behave a certain way, in this case I wanted to zoom rather than select, I had to select the zoom tool. So here, if I zoom on that, I'm not doing a very good job of zooming, so I'm going to reset that. So if you get lost, just select it. So what I wanted to do was select South America only. Okay, and then zoom in on this axis and see what, it looks like I have to select the panning, unfortunately. So here's the pan tool. Now I should be able to drag that, yeah. And unfortunately, I accidentally reselected. This has not been a very good demonstration of linked selections. But let's ask an easier question then that doesn't depend on my mousing skills. Where are the really deep events? Okay, that's an easy question to answer. The deep events do not occur in California. They occur over here, they go over here. And so of the deep events that are in South America, now we further constrain it. Okay, so ignore all the other deep events. Now we're going to see this tiny little bit. These are the deep events that are in South America, and so on and so on. So using this technique, you can tell anything that stands out, some chunk of stuff, some data point, whatever, you select it, and then you can see how that relates on all the other dimensions. Show me only the really tall things that are also wide, that are also blue, but are not red, or whatever. Any combination like that. That doesn't take any coding, it just takes really thinking about what you're selecting on and what you're asking, but you can find out those relationships. Once you do find them out, you probably want to pull them out into a different plot and say, oh, okay, I subsetted to South America and I showed this relationship in an XY plot. But you discovered it this way, interactively. So how did you get to this? All we did is take two plots that that individually work. Here we've added a geoplot and a histogram plot. So I'll just show you that alone they worked. Geo is going to be this plot, and depth hist is this other plot. And then we added them together, geo plus depth hist. And we put them in one column. That's a little trick to put them on top of each other. Okay, now we have this, but it's not linked by selection. There's no tool for the selections. And so we make this call, it's just magic, and just say link those things. Link everything where the same dimension, the same data point is identifiable between plots, or the same dimension is available. So in this case, each one of these data points has an associated depth. Remember our data frame? This is a plot. There's no depth in this plot, but there's a depth in the original data frame. And so I can select on depth, and it'll go back to the original data frame and filter by depth and overlay that here. That's how this is working. So the fact that we have an original data set that has all these columns allows us to see how everything relates to each other. And it all just, HoloViz is saying, okay, you want depth? If there's a depth column, I'll filter on that. And if I select over here, if there's a latitude and longitude column, I'll filter on that. And you have 50 different plots. They might not share anything in common with each other, but if they trace back to the same data that allows you to select and filter by that, this allows you to explore. So anyway, this is called linked selections or linked brushing. You'll have to read up about it and think about it. It's super easy to invoke. It takes a lot more work to think about it. What am I doing here? What am I trying to understand? But I tell you, it is worth it. It lets you not do code, but just click and point and think and answer questions just iteratively and really explore a data set. Yes, Scott?
Can you link plots that are rendered with different backends, like a plot?
Probably. I don't know that. Yeah, try it. You can certainly link data shaded plots with other plots, and that's weird because data shaded plots are just images. But it's okay, because if you think a data shaded plot is an image, you draw a little box on that image, or even draw a little lasso on that image. That becomes a shape, and you take that shape back to the data set and you filter on that shape. It doesn't matter that it was pixels by the time you saw it, as long as you can capture that shape and you know what dimensions it has, latitude and longitude, this little lasso whatever. So if we do a lasso selection, eventually that's a polygon, right? So it captures that polygon and it queries the original data set. So even if this were data shaded and it's just a bunch of pixels, it doesn't matter. If you have the data available, because this was never a plot, it was the data that looks like a plot, it goes back to all the way back to the data, it does the filtering based on that data, and then that's what you see. I'm sorry if I'm blowing your brain. That's how it works. Yes?
So does that operation working correctly depend on you having chosen the right kind of plot? Like if you had a scatter versus a points, you try to
Yes.
that's where that
That would matter a lot. That's exactly, there's probably text in there that says that, but exactly right. If I do a selection here, it's only a 1D selection if this were a scatter plot. It's a 2D selection indexed on X and Y if it's a points plot. And that matters because when you go back to the original data set, you need to be querying along the indexes, the independent dimensions, and then you can filter based on that, but you query based on the independent and you filter based on the values. At this level, you can actually do it on anything. But yes, that's one example of where it really matters. Smart. Okay, so all of this is all just this one call. So that's the only code that's anything new here. This is actually implemented by John Meese. He now works on Vega Fusion, if you've ever seen that. That's kind of a version of Data Shader that works with Vega. So he took a lot of the stuff that we were doing and applies it to another area. He's got really cool stuff there. Anyway, thanks to John for implementing all of this for our ecosystem. By the way, once you have selected a chunk, let's select something small. Eventually, it'll combine all those selections, and at some point that becomes your selection. So you've got your original data, and that's the main plot, and then you're overlaying a selection on top of it. Now you can get at that selection. So if you wanted to further explore it with Python code, you don't want to just look at it. You can easily just get it. Where's most severe come from? It's in here somewhere. I don't want to get into it, but you can access everything and you can work with things in Python. So you go back and forth between interactivity and, oh, I don't know how to point and click, but I know how to say it in Python. You just go back and forth. Okay, so this was a pretty simple idea, but I want to belabor it and say, hey, this is super, super powerful. This is at your fingertips. And if you think, and this took me a long time to realize as a grown-up scientist, so thinking about dashboards and thinking about plots, that realize that's really all that's all it is. You look at a Nature paper and it's got these like 10 different things. Each of them is different views of certain dimensions of some underlying data. They're trying to show you the relationship. You go to some dashboard and you see how these things relate. They're almost always trying to show you how these different dimensions, does your height correlate with your intelligence? Well, of course it does, because I'm tall, but you ask a question like that and you ask it of the data and you try to understand it. That's what any of this does. That's fundamentally what creating figures is, and that's fundamentally what making an app is allowing you to understand those multidimensional things. Because if you only had two, you would plot it and be done. All the hard work is when there's more than two. Okay, so that's it for plotting. I think, actually I don't remember which one Interactive Pipelines is. Yeah, that's it for plotting. So that puts us basically at the halfway point of the tutorial. Time for another break. When we come back, we'll assume that you will have learned more and more about plotting, and whatever you want to plot, you can individually see it. And then you can think about which ones do you want to see? Remember the concept of a dynamic map. Not just an image, but which image? Selected from which time, for instance, a time widget, or from some other thing that controls the things that you're seeing. So if you're thinking about it that way, and you want to build up into some support for helping you explore your data or helping you share your data with others, that's what the second half of this is. And it already got you pretty far because you have all this out-of-the-box link selections, you have the out-of-the-box group by that gives you widgets, you get overlays, you get a whole lot already without leaving the hvPlot interface. So that, remember my point, you try to start with the API that you already have, and then we snuck in a few weird things, a lot of weird things, but most of your work is done with the standard API. And then at this point, we'll leave that API and we'll say, okay, now I'm ready to make an app. Now I'm ready to really just directly try to put in some interactivity, directly try to say, I don't want to think about, I want a slider, I want to go from this to this, and I want to use that value to control this. That's what everything else is going to be about. So another 5-minute break, and we'll attack that. Unless there are any general purpose questions you want everyone to hear. Otherwise, you can talk to me. Thanks. All right. Hopefully had a break. If you're really industrious, you probably noticed that I've just breezed right through various exercises along the way. It's supposed to be an interactive tutorial, but then I get talking and then I just don't stop. I apologize, but all the material's there. You can come back to it, and you're going to need it in a minute. So hopefully you're trying out little things, and there will be time that you're on your own and we're coming by to give you therapy or advice or whatever. So let's try to get to that. And we'll try not to be very ambitious about our dashboarding, but just give you a flavor of what it means to build an app or a dashboard with these tools. So to dive right into that, whenever you've seen a widget in any of these plots, that's a panel widget. Panel is where we get our widgets from. It's actually also a bokeh widget. Fundamentally, so if you've heard of SciPy widgets, bokeh is a completely independent set of widgets. You can use an SciPy widget in panel, and you can use a panel widget as an SciPy widget, but they are different things. And they were just independently developed by different people at different times. Bokeh widgets are older, I believe, since bokeh itself is so much older. But basically, they're widgets. They do certain things. So we use panel widgets in these tools. So in HoloViz, whenever there was a widget, that was an automatically generated panel widget. Here we'll talk about explicitly creating a widget, and then you tie it to something and do whatever you want. So let's get some panel widgets in there. If you use panel, there's this thing called panel extension. There's also an hvPlot.extension. HV.extension. hvPlot is optional, but it's actually called by this little magic here. I maybe should explain that. If you do import hvPlot.pandas, it installs the .hvPlot calls on your pandas data structures. So that if you do df.hvPlot, well, why did that work? Well, it worked because you imported this file that went into Pandas and stuffed it on there. Pandas actually has a mechanism to allow that safely. Other libraries don't. We stuff it on those anyway. So we make hvPlot available. But we only do that impolite thing if you ask for it. And so if you import hvPlot, it won't do that. But if you do import hvPlot.pandas, it will totally do that. It'll put hvPlot directly on there. Otherwise, you have to do it a more ugly way as a user. So anyway, and that also calls hv.extension. What that does is let's say you're in a notebook, it loads in a bunch of JavaScript. None of these plots would work with about a big pile of JavaScript. That has to be there. And so at some point, there's going to be a call that pulls in a bunch. This is Panel's version of that call. It says, it allows you to do some options, but it also lets you pull in like extra JavaScript. You want to do latex rendering? It's not loaded by default because it's a big chunk of JavaScript that slows things down. You want it? Sure. Specify it here, it'll pull it in. So there are various options that you can say, give me more JavaScript. So there's this concept here. I'll try to gloss over it. It needs to be there for certain things to work. Just copy it from an example, you should be fine. Okay, so here I am. I've started up something. All I really needed to do was this, import panel as pn. And if I did that, I can create a slider. If I go to panel website, it's panel.holoviz.org. If I go to the component gallery, I can see there are tons of widgets. If I just scroll down and find the widgets. Okay, there are a lot of widgets. Like I'm going to use sliders here, but you can see there's every widget. You can edit JSON, that's a widget. You can make selections. You can turn speech into text. That's a widget. When did that get there? I totally don't know what that is. Apparently there's a widget for speech to text. There's a table widget where you can edit the individual cells. Text editor, video stream is a widget. All of these things are, what is a widget then? A widget is something that is worth listening to. You listen to a slider because you care about what the value of that slider is. You listen to a video stream because you want some stream of images. You listen to this speech to text, whatever that is, and you'll get a stream of text out. So those are widgets. You can use any widget you want. Here we'll use kind of the prototypical widget, a floating point slider. This gives you a floating point number in a certain range from start to end and some initial value. Okay, so by itself, it gives you a slider. Even this took magic because as you drag it, there's Python code that's executed and it updates this display. I mean, maybe that's already done in JavaScript. I think that's Python though. But anyway, this is a widget and some display of it. So you can get any widgets. Now, what are you going to do with them? Well, you can ask it in Python what its value is. It's currently 3.9. It says it's 3.9. Okay, you can see how you could work with that. In a Jupyter notebook, you could put some widgets to the top, and then later you just use the values of the widgets. That sounds cool, right? That's easy. It's not super interactive, but it does allow you to type in some values or get some user input and then work with the user input. You can also set it. Unfortunately, when you do it, it goes off screen, but I just set it to 7 and it updated here. So this is a kind of important concept. These things across Jupyter cells, it doesn't matter that they're across Jupyter cells. There's an underlying event loop in Jupyter that goes around and updates everything. And if you're on a standalone server, there's an event loop there. So if you've changed the value of it, it eventually gets back to that and will update the display of it. So it's reactive. We'll get to that concept, but really you can just treat it like you can set its value and you can read its value. And so I set it to 5, it's 5. I change it, and I check the value, it's new. Okay, that's fundamentally what a widget is going to give you is some stream of values. Okay, but you noticed I had to rerun this cell to get the new value, because this is not a reactive. I can make that be a reactive display that reflects it, but it's not. Right now, it's a value. Want the value? It gets the value, then it prints 2.5. So the return value. So if I print this, look, if I print the, well, that's 1.3. So this is probably too much of a digression, but anyway, you can get the value if you wanted to, but it doesn't automatically update. So now so we need to do something that it will respect the value and reactively update something. That's where we want to get to. And we want to get to it in as simple a way as possible. And if we're using hvPlot, it has this convenient way to get to something reactive. It's called interactive, but it's kind of the same. It's the same concept. And so let's get a data frame. Just make some Python. All we're doing is kind of, we show a few values, we select a few columns, we define some, this is all just Python. So we do some Python. And then if you do that Python, you end up with these 5 rows, and they happen to be the ones whose magnitude is greater than 5. Okay, so immediately the question could be, well, what if I wanted to choose that threshold based on a widget? So how do you do that? How you do that is, instead of passing 5, you pass the widget. Okay, notice that? Now this is deep magic, but it works. If you pass the widget as the value, this is all set up so that it respects the value and it triggers to update the display reactively. It knows that mag slider has changed, therefore that the result of this expression has changed, therefore that the display needs to be updated. Okay, so that is all it takes. Well, it has one little bit, is that you have to enable this because this is crazy magic. What this crazy magic is doing is, instead of your data frame, you have what's called an interactive data frame. What is this DFI thing? What the heck is that? It is an interactive object that is a wrapper on a data frame and supports all of the methods of that data frame. So if this is a Pandas data frame, it supports every method of Pandas. If it's a Xarray data structure, it supports all of Xarray. It copies the entire API of Pandas onto this object for the sole purpose of deferring the execution based on some parameter that it needs to re-update all of the time. So this is now just like the plots that you saw. They weren't really plots. They were just things that when you happened to look at them became plots. This is exactly the same thing. It's not really a table. It's an object. This object here is an object that is reactive whenever it's given a widget. Let me see how I can explain this. This is an expression whose value depends on a widget. hvPlot Interactive is smart enough to build up the components of this expression and replay them whenever that changes. So this is a lazy deferred pipeline. That's why this is called interactive pipeline. So it's super easy to use. It's hard on your brain. So what it's doing is here is you changed your data frame to an interactive object, and if you just do df2.head, df2.head, it just acts like a data frame. It does all the things a data frame does with the DFI. Yeah, well, sorry, you can't even tell the difference. You shouldn't. Oh, anyway, it gave you the result. What is this method? What is this warning here? It's because you're being stupid and there's no reactivity. Why did you do that? It's telling you you're probably doing something you shouldn't do, which is you have an interactive thing that doesn't depend on anything. So maybe you ought to put a parameter in there. That's what this very long method is saying. Perhaps you should put in a parameter or a widget. And that's where I have to explain parameters and widgets. A widget has an associated parameter, which is its value. The slider has a value parameter. You check what is the value, what is the current state of that value parameter? What is the value of the value parameter? It's 1.2. And it is warning you that it checked all of this and found nothing that it could be reactive to, so you probably did an error. But otherwise it acts exactly as the original DF2 did. So all it is a copy of your data frame that's in this nice little wrapper that acts exactly as it always did, except if it detects, it keeps track of, it traverses this little tree of expressions here, and if it found there's something reactive, it puts it on a list of dependencies and checks it. Whenever one of the dependencies is updated, it re-triggers it everything. And so you don't have to think about it. You just think, I can always just pass a widget for any value. And then it just works. Just think, I've got an expression. If you know how to write an expression in Pandas or an Xarray, then you know how to, if you can write this, instead of 5, you just pass in your widget. That's it. And it almost always works. There'll be some weird combination of like, oh, well, it's not passing number 5, it's passing a data structure that contains a data structure that contains a data structure that has the number 5 in it. And you put the widget in there and you realize, oh, wait a minute, that hasn't been mirrored. There are limits to this magic. But in all the normal operations you might do, typically they work. Like if you want to select something, filter something, call a method with some parameters, any of those things, that just works. So immediately, so this is trying to say that panel, you might think of panel as a dashboarding library. Sometimes we call it that. This is totally not dashboarding. All it is I care about a value, magnitude, I want to see how that affects something else. That's it. It's not a dashboard, it's just getting your work done on a daily basis. This is just, I don't want to type in the number 50 different times. I just want to see, oh, how does it change? I'm going to look, oh, it looks like it's Ecuador. Now it's moving to China, Taiwan. Oh, okay, so if I go for different magnitudes, it's just a random sampling. It's not that useful. But this is to show you it has nothing to do with plotting. It's just, if the output of this expression were a plot, this would be updating a plot. It happens to be a data frame. It could be anything. It could be a string. It could be an image. It could be whatever. It could play a little video. I don't know. Whatever it is going to dynamically trigger. So this is what's called reactive programming. And the great thing about reactive programming is you don't have to learn it. You just do it. You just say, if there's a number, that's a widget. If there's a string, that's a widget that returns string. Anything that's the right type, you stuff it in there and it just works. And it reactively updates and reactively triggers. And there's a lot of magic required to make that happen. But It is really convenient. So, so here's something where it's returning a shape. And like, that's not a plot. Like so this is basically going to tell you how many things there are of a minimum magnitude of 0.7. There are a lot, 1.5 million. How many things are there of magnitude 8? Oh, there are 7. Okay. And there are always 6 columns in this data frame, so maybe that's not, maybe it should be that. That's probably more useful, right? But I don't have to, I'm not making a dashboard or doing complicated, I'm not doing callbacks or events or watching, I'm not doing any of this. I just thought, here's an expression, I want a different expression. I don't know why we didn't always do that, but I saw that we should do this, we should take the first step. And like, that's supported, okay? Or it can be a plot, which is obviously what you're expecting to do. But it doesn't have to be an hvPlot plot. This is a matplotlib plot, nothing to do with hvPlot. In fact, the reason we're using older versions in this tutorial is that we tried to get this ready for the tutorial, and it's almost ready, but not, which is to take this .interactive stuff and take it out of hvPlot, because it's literally nothing to do with hvPlot. It just happened to be where the right dependencies were. Because you can see it has to do with strings or numbers or matplotlib plots. So we've put it at higher levels, the library called param. And so you can use it with anything ever. You don't have to choose any of the rest of our tools. You can just have this sort of interactive ability to have responsive reactive plots. But for the purposes of the tutorial, what I'll actually show you is using it with, in this context, with HoloViz tools. So here, if you decided you want to have this widget, then you just have that widget. And all you did is, and it's exactly the same thing as this, but I guess you're going to get the you'll get the warning, which is that, what are you even doing, you moron? Okay, back to how it's supposed to be. So you could just, you might want to turn that off because you just use it and forget about it. But here, it's assuming you're using it for a reason. Okay. Okay, here's one actually using an hvPlot plot, which behaves much more nicely because it actually updates the hvPlot plot in place. It's that smart. So here, it's reevaluating this entire expression, and it's noticing that only one thing changed, which is the underlying data that's used in this plot. So it doesn't actually redraw the plot always. It just, because otherwise you'd be seeing flicker here. It's updating the parts that matter the most, that actually change, sorry. Okay, quickly going from that to try to build up an actual example that's meaningful. Here's a widget with the date range slider. That's a very obvious thing to want to do, is look at a certain range of your data. Just everybody wants to do that. If you look at the value of that, that'll be a tuple because it's a range. And so you can filter by that tuple. So here we're just showing that the tuple starts here and ends here, which is presumably these match. They look like they do. Yep. And if you change the range, it would update. Okay, now let's go ahead and now we're, and we only put one widget in there. You can put as many widgets as you want. You can control everything. Have a bank of 100 of these widgets, who cares? Here there are two, there's one widget for the magnitude. So that's this filter here, but it's also filtering by the date, and you just pull out, most widgets have a parameter called value. Here you have, there are two. There's a value start and a value end that are the beginning and end of it. The value is a widget, is a tuple, and it's, Pandas doesn't accept a tuple. So we pull out the two separate things. It doesn't do the filtering by tuple, which is irritating, but anyway, we have to pull it out separately as two values and then filter those separately. And then we can filter whatever, and of course it responds to those appropriately. I don't know why that happens. Probably some reason. Oh, because it changes the height slightly, and now I'm hovering over it. Never mind. Okay. Here, if we did mag, let me just illustrate here this concept of parameters. Mostly you can forget about it. You can just think a widget as a value. But underlying it, there's this thing called a parameter, and actually that's what's important, not the widget. The widget's just a way to update a parameter. So let's look at those parameters, because it tells you here. So mag, that's the widget. Print mag will tell you the type of the widget. It's a slider with these things, currently value. So then if we do mag.value, that'll return a value. And that's the same as doing mag.param.value. No. Yeah, okay, that's an object. And then, oh, sorry, it's the same as doing mag.value. So mag is a parameterized object. So help mag. Let's just really make this super concrete. It's a widget. When you did a help on a HoloViz object, that was a parameterized object. It's an object with all sorts of parameters. It's the same parameter concept. Everything in HoloViz is a parameter when you're messing with it. Everything in panel is a parameter when you're messing with it. When you're reacting something, it's a parameter. What are the parameters of this widget? Okay, this widget has, oh my God, so many parameters. Look at all the parameters of this widget. Almost always you only use the one thing, you use the value. But you can trigger off of all of this and you can update all these things. Like you can trigger off it becoming disabled. You can do some widget to set another thing to disabled. You can change the color based on some other widget. Everything is a parameter, everything connects to everything, everything can be reactive. It's all a nightmare. It's amazing, sorry. It's a nightmare if you actually want to follow all the paths. It's amazing if you just think it should work and it works. That's amazing. Don't try to follow the paths. Anyway, so that's what I'm saying. The mag here is a widget. It's a widget that happens to be of type float slider. Float slider can be configured with some parameter values. This shows what those parameter values are. And if you actually ask for the value of it, then you get the value. But you can also ask for the disabled. And it's not currently disabled, and any other parameter about it. So whenever I say widget that you can throw in a widget, you can throw in a parameter. And every widget has you saw it, dozens of parameters. Every HoloViz object has dozens of parameters. It's all parameters everywhere. That's the library param. That's as much as I'm going to say about that. But that's how everything works. And in certain cases, if you pass the widget, it knows, oh, I needed a value. A widget's not a value. It's going to check for the value parameter and use that. So there's some shortcuts. And the result of that is that scratch your head and like, how did that work? Wait a minute, why did that work? There's a little shortcut in there. If you don't think hard about it, it just works. If you want to think hard, you'll realize, oh, okay, for the widget, it's looking up the value parameter of the widget and it's turning that into a value and it's using it. Okay, got it. Or you just forget it, say, oh, a widget works, done. So that's what I encourage that. Just, if you think it should work, try it, it should work. If you want to, that's great if you have an expression. What about the case where you can't do df dot something because you don't have df yet? Like you need to choose the file name, for instance. Then you're going to have to write a function. And here's a function. You can write any function you want. You can make that interactive as well. That's a special way you do that. You just say you're going to bind that function. So this is the function of one argument. It could be a function of any number of arguments. You're going to say for that argument, I'm going to tie it to this widget. And at that point, that's something, even though that's a function call, it's a function call that you can call .interactive on, and it works all the same. So before, you could do .interactive on your data frame. With this, you can do .interactive on your function, and your function can literally be anything. Whatever that function is can now be made interactive, and so it can choose your data frame typically, or it can choose, you can do anything you want in that, and then it all works the same. So let me just actually demonstrate that. If you don't follow this, the takeaway message is just The things that didn't work, you have to learn this thing about functions. You have to say, oh, okay, you know, there wasn't a single expression that could express that. Okay, because, well, for whatever reason. Maybe you could have expressed the pandas loading from a file because you could have put a pandas argument for reads CSV, and then that could have been the file. So yeah, that can be expressed. There's got to be something you can express. Whatever it is, you drop back and you write a function for it. Anyway, here we've made a function, and we've got this selector widget, and we gave it these options. And now once those options are around, it selects on that. Now there don't happen to be any quarry blasts at that time, or any explosions in this first two. So, but there are earthquakes, I guess. So anyway, the whole point of that is that, number one, take a number and replace, or a string, take any Python type and replace it by a widget that returns that type. Done. If you need to write a function, you can write a function and then call that interactive on the bind, and then it'll work. Okay, and then this, I have to apologize. We will fix this. You have to do, I don't even know if I want to mention it because it's going to go away, but basically you have to learn a little bit too much here, which is that if you want to do link selections and the thing that you're selecting on is this .interactive object, link selections is implemented by HoloViz and it doesn't know anything about interactive. So HoloViz objects, you try to call link selections on two things that look like HoloViz objects, but they're really interactive objects. Link selection just said, I don't know. But we're going to make link selections a little smarter now that we have the interactive stuff. So that link selections, it's something that returns a HoloViz. Okay, I can work with that. How do I get to a HoloViz? Okay, yeah, that's it. So basically, we have these two things. This one, the mag hist right here, and this one, the depth hist. Both of these look like HoloViz objects. They display as HoloViz objects. Really, they're interactive objects. So if we do that, and again, I apologize. This is way too much detail for you to have to know. I've been pretending you can get by without learning this stuff, and we need to make it true. So mag hist, that is an interactive object. But we can get the how do you, there. What is the call for that? You call .HoloViz on it. Mag hist is an interactive object. If you do mag hist, it's automatically updating based on these widgets, right? So this is the normal interactive workflow. You get some widgets and you get something that's displayed, and when you drag it, you get something out. Now this is not a HoloViz object, but it happens to have a HoloViz object in it. And if you asked for that HoloViz object, number one, you don't have any of the widgets because you just asked for the HoloViz thing that's in there. Now you can take this thing and pass it to link selections. Again, I apologize. If you read it, you'll understand it. But if you want to combine everything I've told you today, you have to have this special thing because it's not smart enough yet. So if you want to have interactive, you want to have it widget controlled, you want to have another one, you want to have it widget controlled, you want them link selections, you want everything, you have to do this. And it's for a good reason, but we can still, it shouldn't be something you have to know. All right, and the reason for telling you that is, believe me, we would skip over things that we don't want to tell you. Like, don't get into that. Don't ask about that because you don't need it, right? I'm going to pretend you don't need it, and hopefully you never bring it up. There's tons of that. We're trying to have a theory for what it is a scientist wants to do. Do you think that's ever going to be a complete theory? It is not. But we're trying to make it be a pretty complete theory of the things you want to do on a daily basis all the time, and to have a way out of it when you don't. Here is a place where that ends. So anyway, what we're trying to do is create a interactive data frame with filtering by magnitude. Ooh, hey, you just noticed flickering, right? This is something that I'm pretty sure the more recent ones do not do this, but this is exactly a case where panel can do literally anything. This could have been anything, and it has certain special cases for when it's HoloViz object to only update the one thing that's changed, but it doesn't do that perfectly, and it won't make anything break. But you'll see that, wait a minute, it's doing a lot of work here. It's redrawing the entire thing from scratch as I drag this. I didn't want that. sometimes you have to learn more if you have an opinion like that. And it's a good opinion. You're right. It shouldn't be doing that. Sometimes you have to tell it more information that lets it update only the things that are really changing. So this is a fairly important point, which is that these tools are totally general, and Panel can literally update anything that could be displayed. If it can be viewed by a human, it can be embedded in a Panel thing, and you can control it with a widget. But sometimes you have opinions, and those are good opinions. You don't want it to flicker, and so you didn't want this whole thing to update. You only wanted the data to update. And so often it can figure that out because it knows you never wanted the whole thing to update, but not always. So those are advanced techniques. What are you going to complain about? You got a widget, it worked. It's not great. Nobody's paying you to make a world's best app. It does let you do your stuff. It is irritating, and if you really care about it enough, there are ways to figure it out. It explains it in the advanced tutorial. We won't get to that. Way too much for you to get in one day. But just getting something where you have a control over what it is you're doing and it automatically updates, that's what you should walk away with. You should have that. If you don't have that, we'll talk in a minute. So I'm about to switch to the trying things out. But there's a limitation to the magic, and I'm pretty sure that's gone in the latest releases. But if it's not, there are ways around it. So I'm going to skip over all that. Okay, and then double check where I am here. Okay, so there's a whole section on more and more detailed dashboards and interactivity, and it's only even scratching the surface. Panel is a deep, deep tool. You can build tons of stuff with arbitrary requirements, complicated multi-page apps where every little bit is cached, where everything is connected up. You can use it in production. You can handle lots of visitors. When you handle lots of visitors, you have to be very careful about how much state you store per visitor. You can get into all that detail. That is not today's story. That is the Panel for people who get hooked, and that becomes their job. Today, this tutorial is about when Panel is not your job. Your job is to discover, to explore, to share. That's your job. You're not trying to make the world's best app. So this is just telling you this. There's a little bit more detail here, and then I'll just set you loose. Trying everything out with your own data. Some of the things you can try are these different pane objects. A HoloViz plot, that's a pane. A chunk of text, that would be a pane. An image, that's a pane. So it's like a window pane, P-A-N-E. And if you can display it, that's in Panel, that's a pane. No pun intended. So here's a markdown pane. And so when you're making a dashboard, you're usually going to be collecting some static elements like this, some semi-static elements that are actually driven by another widget, like a date selector. It could be a markdown rendering of the date. And so that's static, but it's also driven, so it's reactive. So anyway, you put stuff together and you put your dashboard together. And previously we were talking about just to control a little bit about the thing you're doing. Now we switched into this other mode of let's design stuff and lay it out and really make it usable. So let's make an earthquake dashboard. We're going to make we're going to add a logo. This is data from the USGS, so we're going to call them out. We're going to, if you care a lot, you can put lots of detail, or you can just say, whatever it is, make it displayable. This pn.panel thing just takes anything. Numbers, strings, images, anything, just stuff it in there and it'll probably display okay. If it's not, you have to look it up. But it has a priority list. So a string, first it checks, does it end in JPEG? Oh, okay. That's probably a URL for a local path. Is it a URL? Oh, it's the URL, I'm going to fetch that. And so it's got this whole list of priorities, but don't worry about that. Just stuff it in there, see if it displays. If it displays, be happy, move on, don't learn it. This is back to that diagram. Don't learn the stuff you don't need to change. But if you do, if it gets the wrong answer, you'll need to look up, oh, this turns out I wanted that to be markdown. Okay, I explicitly say markdown. Okay. So by default, just try to throw it into pn.panel. And so we're going to get a title and a logo. This is where you're going to really want to start to play around. So this is all just, you're going to be doing it yourself. So what is this thing? It's a panel image PNG pane, okay? And I assume that, yeah, it's a PNG, okay. and so on. Okay, and then there were widgets, there were panes, and then there are collections of panes and widgets. That's a panel object. A panel is composed of panes and widgets. So the entire thing is a panel, and then there might be a pane that shows something, and a widget that you listen to. That's the difference. So a pane is kind of one way. A widget, you can ask what's your current state, and you can listen to your slider widget. You could listen to your table widget because a user might have filled it out. You don't listen to your table pane because that's just one way display. Hopefully that makes sense. If you're putting some together, some of them are just for you to look at, some of them are inputs. If it's a control or an input, that's a widget. If it's just communicating with you, that is a pane. And then you group them into panel objects. The typical ones you'll use are row and column, but there's also tabs, there's accordions, there's all sorts of ways that you can take two things and either display them on top of each other or next to each other or serially. Whatever those are all panels. So here we're going to get the, we're going to make a row of the title and the PNG, and we're going to set a height on it. Okay, that's a thing. That's now a unit called the header. We made a header out of these two things. And then now let's load our data. We're going to use the small data just to make it easier on ourselves. And we're going to do the earthquakes, and we're going to get the population density. You're seeing everything is going to come together in this. Everything we covered all day is going to show up here. Not data shader, I don't think. But the raster could have been data shader. It's the same. It's just a lot cheaper. Okay, now we're going to make a mini dashboard. This is OpenMP. You're going to ignore that. It's deprecated, but it works. So the later version, we'll get rid of that warning. So here we've created a miniature dashboard that has some markdown, an image, and an overlay of a raster and some points. Okay, so that's a lot of the things we've talked about. This particular one, we can do something called showing it. That opens a really temporary web server so you can see what it would be like if you served it. So you said, this collection of things, I'm ready to share it. What would it look like if I really did share it? Now you're not sharing it, you're showing it on your own machine. It's not really listening to external things. It's a temporary little thing, but it shows you what it would be like. So it's a convenient debugging tool. So that little thing that I had, that has these 3 items, or 2 items plus everything that goes in that plot, that is a shareable entity. This is now essentially a web server. It's responsive to the size. It's ready to plot stuff and let other people look at it. So I'll ignore that. Where are we? Here. So here, this was the show. So again, this is mainly for debugging. But what we usually do is we mark it servable. And servable doesn't do anything in the notebook. But if you save it to the notebook and you do panel serve and then the name of your notebook, then it launches it. What that does is convert your notebook to a Python file, because it ignores the notebook. It doesn't care about the notebook at that point. It's just taking the code out of your notebook. And then it runs it all. If it encounters anything that is of type servable, then that's what will be put, that's what it's going to serve as a web server. So this is your link towards I'm just exploring to I'm ready to actually publish this. And so if you go to Heroku or Hugging Face or any of the things that lets you publish things to the web, at some point at bottom there's a web server that gets started on some virtual machine or container somewhere. That web server effectively is panel serve this thing, anything that's marked servable. And that's your final connection to sharing something. Now, this is a boring thing to share because it doesn't have any widgets, but it's kind of the minimum. It shows you that you can share something. And so at the command line, if I saved that, then I would type this at the command line, and it'll fail, but you probably can't read that. I'm not even in the right directory, so. So I'm in tutorial. So do panel serve, tutorial. There's something in there that's of type, oh, I'm not in, I have to do Anaconda. So here I'm, so if I do which Python, let me see if I can make the font bigger for you to read. Yeah, okay. So here we've switched out of Jupyter for the first time. The rest of the stuff doesn't depend on Jupyter in any way. It could have been a .python file. It doesn't matter. It's totally ignoring Jupyter for this serving part of it. Here I'm not in the right Python. This is not the environment for the tutorial. So I do Anaconda project run, and this should fail. Oh. Whereas this is the environment where I installed Anaconda project. So project, sorry, wrong. So this will fail because I already have something running on the default port. So it is going to. So what it does though is to try to take this IPYNB file, calls nbconvert, if you know what that is, that converts it to a Python file. Then it runs the Python file, and if then it will run the Python file, look for servable, and serve that. So let me go ahead and get to the right place to do this. So that's tutorial. So that failed, but not for the reason it's supposed to. Let's get it to fail for the right reason, because it's an important debugging thing that's going to help you. So let's make it fail so you know what to do. So what this is doing is starting up this environment that's in this directory, and then running this command here in that environment. What you need to be able to do is to specify the port that it's running on. Port 5. But there's another error here, which is the path. I don't know what did I tell myself to do? This is to do with where I am serving this from. Hang on. So I'm in this directory. I don't know why it has tutorial. Yeah, I'll shortcut this because there's a complication of using Anaconda project. I'm just going to go ahead and conda activate env default. So what this is going to do is put me into the environment of this tutorial. So now I'm just at the prompt, and now I can do whatever I want. I don't need Anaconda project anymore. This is also a useful thing to know. So now I can just type panel serve and then so on. Oh, and I had I had a typo in the file name, which is the real problem. Okay, so I just served this on this local host. If this thing were running on a cloud server, the same command executed on that cloud server would put it on. You would have to specify whatever port is open on that cloud server. And then if somebody visits that, which could be your buddy in another country, goes to that URL for that cloud server, then they would go to your dashboard and find this running there. So actually, if we look at the original file, you're probably wondering, wait a minute, why does it have this template and this these widgets? We didn't even have those. So we have to look back at what we were doing, which is that later on in here, we've added these widgets and made not just the mini dashboard, but the final dashboard. And we hadn't gotten to that in Jupyter, but like I said, Panel doesn't care about Jupyter when it's serving. So let's go ahead and pause that, deconfuse everybody by going to the end of this notebook, and you'll see what it's actually ended up serving here. Because I don't even think I saved it earlier with that. Okay, so here is the thing that's been marked servable in what I just loaded. And at some point, it must have specified the template. Let's see, template. Yeah, okay. So the story from the top then is, we called pn.extension, we gave it some options. We happened to specify this template, which gives you this fancy thing that you saw that result, like where did that come from? It came because I happened to have specified that there'd be a template. Otherwise, it'd be just the blank things you saw before with no, it'd just be the widgets and the plot. But in this case, it's putting them in a template. You can choose, there are lots of templates to choose from. This one's a handy one that lets you hide the controls. Has a loading indicator. It's handy default stuff. So basically, the whole story then is you wrote your notebook, you imported some stuff, you had an opinion about a template, so you stated it. You said that you wanted everything to stretch sideways anyway, so it fills the whole screen. So that's why when I do this, it stretched. You notice it only stretched in width. I wonder what happens if I do it vertically. Doesn't seem to be stretching vertically, because you do stretch both for that. So from the top, the whole story is you loaded some stuff, you configured Panel to use a template, you created some chunks of stuff, you laid them out into panels, you combined the panels into eventually an app with widgets and some interactive triggering stuff. And you made a whole final app, which is this, which is a column of some rows of some tiles with some linked plots and a table. And you have another row in that column, and that row has 2 histograms. And you marked the result servable, and you got this. And now, where are those histograms? Oh, they're down there. Okay, so they were off screen. So there's now you have these guys that are attached to some filter that's going to be running on, probably on this. Oh, I've screwed it up because I marked this servable and it stuck that in there. Basically, it just concatenates everything you mark servable. Okay, I'll stuff it in there. So this is not how it was intended to look. It's got this extra plot here and things connected to it. Link selections between this plot up here, but you can't see that because the other plot is now so far away. These plots down here, so you can filter based on magnitude, and that'll update the other plots, and that's everything. So that's as much as I'll tell you about anything. You can read a lot further. You've learned how to avoid flicker. You can tell I'm getting tired. So if I'm tired, you must be tired incorporating new concepts and trying to keep up. But the whole point is that everything we saw about plotting can show up in your app. Everything you saw about widgets, put them in your app. Connecting up to a widget, just use .interactive. And you just stuff in the widget in any sort of filter or pipeline or anything. And you want to link between the plots, you call link selections. And you display whatever you want, whatever dimensions you want, however way you want it, as a table, as a plot, and you make the app. And hopefully you're not just making an app to look cool, you're showing a bunch of things that you decided. I want to put this next to this because they're related. I want to put it over here and I want to filter based on that because I'm interested in that, or you should be interested in that. You're thinking of what it is you're trying to achieve, what you're trying to convey, and that's what goes to an app. And usually you get to this stage with a template and a full thing pretty late in your exploration. It's, okay, I looked at 150 things. I put 7 of them here. And the new versions of it have hover for tooltips. So you can put it in there, or you can put an explanation to the user. You can guide the user saying, hey, you might filter by magnitude and here's why, or whatever, and that would show up on the hover. And then you put some text down here in the sidebar to explain what this is for. And eventually you've honed your story, you've honed your thinking about this problem, thinking about this data set, and you, in your opinion, this is how to approach this data set for this purpose, and you convey it to other people, and you've achieved something. So starting from 8 o'clock this morning to now, that's the hope, that you have achieved the ability to do that. Even to understand that it's a thing that needs to be done. Like a lot of people in the world, I don't think about dashboarding that way, but if you're thinking about it in a data-centric view, which is what we're talking about here, we're talking to scientists and analysts and researchers, you're fundamentally wrestling with some data, maybe multiple sources of data. How do they relate? How do you understand them? And how can you practically put it together into something you can work with and someone else can work with without becoming a JavaScript front-end engineer and thereby forgetting your science. We want you to stay in your science, stay in your domain, put these together, solve problems, and communicate. So now, in the time available, well, you can answer some questions for a minute, but after that, I'd really love if you guys think of some data set that you know of, or just, even if you don't want to work with data, just look at the panel website, look at the different panes, display them next to each other, just get a feel for it so that you leave this room having done it. Because that is super important that you walk out with this power. Not that you've heard me talk about it and drone on about it, but that you know yourself, oh yeah, I could do that. I want people to walk out and say, yeah, I totally could put a widget attached to this audio stream that does that. Yes. So if you still have energy and you still have the interest, I'd love if you spend some time with that. Sophia and I can walk around. Scott can walk around. I'll volunteer you to help anybody who hits a roadblock. You will hit a roadblock immediately. But hopefully the real simple roadblocks that you hit immediately, and we say, oh yeah. You need, put a parentheses. But try to find something that interests you, something that spoke to you about this work, and then try it out with your own stuff and hit the roadblock, and then we help you and we get you over your first 3 or 4 roadblocks so that you get something under your belt. That's our goal, and we'll go from here, unless there are any questions from the start that you think are relevant to other people.
I had a quick question.
Yes.
About labeling things.
Yes.
If we wanted to change like the axes and variable labels,
Yep.
is it best if you like go back into like, the Xarray or the Pandas object and rename that, or do you do it in like an object?
If you're an Xarray, I would always try to put as much onto that object as possible, because Xarray has a really good model of storing metadata associated with each dimension. It's really thought about that. Pandas, like if you want to set the units, there's not a great place to store that on the Pandas data frame. There should be a metadata associated with every column, and you just stuff that in there, and if you save it to disk and you bring it back, look, it's got the same unit, so that when you plot it, the unit's just always there. Unfortunately, Pandas doesn't address that, so you always have to keep re-adding in the units. That's super bad for science. You're going to make a mistake, but it is how it works. So if you start with a Pandas data frame, you're going to have to keep refeeding in the stuff that's in your head, and there was an original data collections head, but has been lost between you and there. With Xarray, you can put it back in there, export it to things, and it's still there when you come back. So if it's going to be there when you come back, I would strongly recommend put it there. If it's not going to be, well, I apologize. Okay. Yes, in the back?
Oh, I was doing about Xarray.
Okay. So. Yeah, that's a great reason to use Xarray. They treat your data seriously, as the units and the metadata associated with each one is important and worth preserving. Yes, it is. So, and that's a reason to use Xarray even for columnar data, because you can use it for that, and it will store that. It's not really set up to make that super easy, but it does respect that. Yes? Hi. I heard half of those words, so. Does panel use tornado is the question. That has changed recently, and panel is, there's whole sections that I've not talked about. All of these things I've talked about using it as a standalone Python-backed web server. They also work as a WASM-based approach where Tornado is not supported, and it has changed so much. You'll have to ask Philip how that works, Philip Rudiger, but it doesn't have to use Tornado. It has somehow it works in cases where Tornado is not available. I don't even know the details. So it is based on event loops. Jupyter is originally based on Tornado event loops. There has to be some event loop. It doesn't have to be Tornado. Don't trust me on anything. All I know is it does work in cases where you don't have Tornado. Okay. Yes?
Question on the widgets. The slider was a good example. Let's say I wanted to, I'm asking you, can you do this? Let's say I also wanted to have a drop-down menu that provides the same options as a slider and let users choose if they prefer sliding or but have that do the same function.
Yes.
Can you do that?
You can do anything. Okay. Yes. That's not terribly hard. You can do that, and you do that by expressing dependencies between things. So the stereotypical dependency is you have a widget for country, continent, and a widget for country. And if you change the continent, then the countries need to be updated. And so that's a really concrete, oh, how do I do that? You express dependencies between widgets that way. And so basically you make one widget watch another widget. And then that's how things like that happen. Again, each widget is full of parameters. Each parameter can be referring to another parameter. That one could be, you can make all these chains and then everything updates. As long as you express the dependency chains, things update appropriately. So it can get pretty hairy if you need to, if you have a lot of opinions and you really want to control how it works, and eventually you end up, oh, I need to drop down another level. Many things can be easily expressed though. Okay. All right, well, again, if you have the energy, and I totally understand if you don't, try stuff out and we'll help you. And just put up your red stick, well, put up any sticker and we'll come talk to you. Okay. Yes?
I have one other question. On your documentation for the hvPlot website, there's an embedded focus figure like in the documentation on the homepage.
Yep.
Is that something that's easy to do if I have
Yep.
a website and I want to embed a figure?
That's what I was referring to as WASM and Pyodide Jupyter Lite support. Panel, if you go to the panel website and you look at the various, I don't know a good example, but there'll be, well, maybe a widget one. There, basically, the whole website is live, and it's live without Python running on a server. And the way that works is that it's WASM compiled Python running in your browser. And so you do a panel convert to Pyodide, and that gives you a thing that has been, where instead of its panel running on Python, you have gotten a panel thing that runs Python and then runs the panel inside it. So you get a fully standalone browser-based complete experience. We have only so many things I can throw at you.
I'm familiar, I've used PyScript before.
It is, you can panel convert to PyScript, and as of last week, that had certain limitations. I believe those might be gone by this week. So yes, convert to PyScript is exactly the same set of underlying technologies. So yes, it's very exciting to be able to write Python and then ship it to people and never have to set up a server or start Python. I didn't cover it in today's talk because that does not support data shader for two reasons. One is that data shader relies on Numba. Numba relies on LLVM. LLVM has not been ported to WASM. I'm not going to do that work. Number two, even if you did that, it wouldn't have the property of you do petabytes of data and you only have to have the image go down the wire because the whole thing is now on your local machine. So if you want to do render 10 million points, well, you have to first download the 10 million points and then render them, as opposed to the thing running on the server. So data shader is the one thing that really just doesn't work and doesn't make sense in this scenario.
Yeah. But I could have like a server with like graph equals true.
Yep.
Essentially streaming images to a client, and that client doesn't necessarily have to have Python installed.
Well, that's how it normally works, yes. So that's the typical case, that's right. Yeah, so you've launched a web server in the cloud, it's running Python, your client connects to it with a web browser, and that's the only connection. Same for Jupyter. You launch a Jupyter server in the cloud, you talk to that, your client doesn't have any installation. So that doesn't require WASM or Pyodide or PyScript or anything. But if you want to get rid of that server in the cloud and replace it with just a file server, then you use WASM. So it's all amazing. It's all total magic technology, but all works.
Yeah, I appreciate the question because in my computing environment, they don't, well, one, it's fairly isolated, and two, they don't like people running servers and clients on their network. There's a great lockdown, so having a local is helpful.
Exactly, yeah. I mean, it's a massive problem to set up a server. It costs money, it costs administrators, somebody has to watch it, somebody has to worry that it's being hacked, all this stuff. So here, this is an example of that. This is not, there's no Python running on the server. This is Python running in the browser to render these things. It doesn't do anything useful because you can't see that it's dynamic, but it was running Python in the browser to do this if I had some other, if I knew the right, probably this is, oh yeah, this will be an actual demonstration. So this is actually running in the browser. There is no Python on the server. It's waiting for, it's downloading an entire Python distribution into your browser. Now it's tight, it tries to make it real small, but it is the entire Python distribution. And then this is an actual bokeh plot running on my local machine with Python running on my local machine, and there's no server outside of this laptop right now, even though I just visited a normal website. That's all those magic technologies I talked about. So totally should have mentioned all that. Yes, it has been a long year and a half of work for a lot of people, not just on my team, but everywhere in the scientific community, just addressing fundamental issue after issue. And then people in the, you mentioned PyScript. People over at PyScript has been taking something that initially was this big to download, and like it takes 30 seconds before you see anything, to this big, to this big. And then now it's down to like 8K or something in the simplest case. So it's to the point where it can essentially replace JavaScript entirely for certain scenarios. Not that you should necessarily, but if you wanted to, you can. Anyway, yeah, that is an output of your, that's an option just when you want to serve, and as long as it meets the criteria, it'll work. Criteria being no data shader and certain other things.
In Plotly, if I understand correctly, you potentially output objects or graphs as like HTML things.
Same here. Yeah, here, if I go to the, I guess the Param website, most of our websites historically didn't have any sort of WASM backing. So if I, well, this is not a very good example, but basically our normal websites, if they don't have those little gears on them, those are just exported to static HTML, and what it means is it'll never call Python. So you see a plot, you zoom in, data shader never updates because there is no Python. It's just the export. So if you don't have data shader, you won't be able to tell that there was anything if you don't have some special widget. And you can actually configure direct connections to JS. So if you don't want to go the WASM route where you're running Python, you can actually control it yourself to only ever export things that are valid static. And that's a great way to do if you just want to be the simplest, like at the total end of your PhD. You want to distribute something that will just always work and has no complications. You have to do some upfront work, but you can do it. And you don't have to learn much HTML and JavaScript. You will have to learn a little if you want to say, oh, how do I connect to that? You write some JS to connect to that. That's how you connect to that if you don't have Python. Oh, here it is. I wanted to just leave this up as I walk away, which is we're at GNOME Focus. We're about to release a ton of stuff. If you want to deploy stuff, my own company now has an easy way to do it, a one-click deploy. You get it in Jupyter Notebook. There's a little button that says deploy. And Sophia's worked on that a bit, I think. Lots of people who are not me have worked on that. And so you get a certain amount of space for free, and so you can deploy stuff that's backed by Python. And you can do the same thing on Hugging Face. And if you've previously tried Streamlit, usually you'll hit some sort of limitation. So it's a great way to get started and covers a lot of stuff, but it doesn't go as deep as what Panel does. So if you've come from that background, there's a guide. And I'm advertising, this is part of a much bigger story where I only talked about that, those 2 bits. There's a much bigger story about how everything fits together. Stop in at our poster session or search for SOSA at GitHub, and you'll see what that's all about. And then totally cool things. A lot of the things I apologize for are just going to go away and are just going to work. So. Okay, I'm going to wander around. See if anybody's got anything.